Hello, everyone.
Hello.
Hey, Kareem. Welcome to HashiTalks Secure. My name is Benoît Schaatsbergen. I'm a developer advocate, and I'll be your host for today. I'm accompanied by a friend, colleague, and co-host, Kareem.
Excited to see you all here. Welcome to HashiTalks Secure 2024. We've got 2 days of amazing program stuff for you. And Bruno, why don't you take us through a couple of the house rules?
Yeah, for sure. So HashiTalks Secure is our virtual community conference focused on security, where we have a day, like Kareem said, full of great content for you. But if you have questions or comments, we would love for you to interact with us in the chat. And as you do, please keep in mind our code of conduct in this virtual space. So in general, be welcoming, inclusive, friendly, and patient. But also please be considerate, respectful, and professional. You can view and review our code of conduct at hashicorp.com/community guidelines. But with that, let's get started. So we have speakers lined up for you from all over the world, talking about Vault, Boundary, and Terraform, addressing very relevant and serious challenges like the new NIS2 compliance directive from the European Union, or how you should securely access Google Cloud from HP Terraform. Kareem and I are super excited to be the host of so many awesome speakers today, and we are hoping that you're excited too. Our first speaker is Hila Fish, who will talk about granular secret management in HashiCorp Vault using Secret Service. Hila, the floor is yours.
Airflow, and Airflow is a tool to run tasks or jobs. Some jobs need secrets. Hi everyone, thank you so much for joining my talk. This talk will be about a use case that I had in one of the companies that I worked for, in which we had Airflow, and Airflow is a tool to run tasks or jobs. Some jobs need secrets, some don't, and we had some challenges when it comes to secret management, how we provide the secrets to Airflow, how we do it in a secured way, how we do it in one single way so all developers know specifically or exactly how to use and leverage secrets in their Airflow jobs, etc. So I'm going to cover here the requirements, solution, the whole works. But first of all, hi, my name is Hila Fish. I'm a DevOps tech lead. I have over 15 years of experience in the tech industry. I talk about DevOps topics in conferences quite a lot. One of them is Terraform, so that's why I also got recognized as a HashiCorp ambassador, and I am a HashiCorp ambassador for the second year. And this is my second talk about a HashiCorp tool. So Terraform, and now I have a talk about Vault as well. So that's that. And I also help organize conferences in Israel where I live. DevOps Days Tel Aviv is the biggest one. So the agenda for today's talk, we will cover the problems with secrets management and usage. We will cover the solution that met our needs, and we will cover what did we achieve. Spoiler, we achieved success, but in several aspects. So the problems. What were the pains with secret management and usage? So first of all, we had a general problem. There was no decision or standard about secrets management, meaning that we had in the company HashiCorp Vault it was deployed and maintained by SecOps team for the entire company to use. And we should use it because security team said that they are on board. They said that HashiCorp Vault ticked all the boxes and licenses were purchased and it was installed and everything was good to go. But we are not using it. And we had no plans to use it and no priority to use it, and no shared vision to tap into the company vision of having one tool and one centralized place to manage secrets. So that's about that. And one note for you all, it doesn't matter if the company that you work for is small, medium, or a big enterprise. If there is no standard and no overall decision of setting standards, not only about secrets management, but in general, and sharing resources and infrastructure is not something that you do in the company, and you think that reinventing the wheel all over again every time a need rises is okay, then quickly you can find yourself in a scenario of maintaining different solutions or tools for the same use cases, which in the long run is not really viable. We also had a specific problem, no decision or standard about secret management specifically in Airflow. So Airflow was widely used in the department that I worked for in all flows related to data. So the fact that there was no standard or one secured way of using secrets in Airflow was an issue. The way that secrets were provided for Airflow jobs up until that point, before the solution that I'm going to share here, were two ways. Secrets were kept in Airflow built-in connections and variables. And if there is no standard or active decision that was taken, then the users will just use what is available for them, and it makes sense, So in our case, what Airflow offers is not secured at all, and we will understand why in a bit. So this is default. Some use cases did kept the secrets in AWS Secrets Manager. It is secured, but there wasn't really an official solution to use AWS Secrets Manager, so it was an overhead to manage. Some used it, some don't. Some created the secrets through Terraform, some created it manually, so it was hard to really manage it, everything. And this is a very specific problem with Airflow. So whenever you set up a secret in a connection or variable in Airflow, it basically means that you get a secret and you get their secret, and everyone has access to all secrets, because this is how it goes with connection and variables in Airflow. They are shared across all Airflow jobs. Everyone has access to all secrets that are defined, which is a big security no-no. So I assume they called it connections and variables and not secrets for a reason. So that's the thing. Secrets should never be shared with those who don't use it, because it gives more opportunities to exploit them. So free love is not always a good thing. Okay, so what do we want? Depends on who do you ask. Security asks for segregated secrets, and not only security, us DevOps team wanted it too, because we are security minded. Data engineers said, we don't care, just give us one easy way to get secrets, because if we use connections variables, you say it's not secured. And if we use AWS Secrets Manager, you said it's not supported because it's not really the official solution. So give us one easy way to get secrets, reasonable. And when can we have it? Once design and implementation are done, of course. So when we were done, we provided them and they used it. So let's go over first the requirements and then the solution. So the high level requirement is that security won't be shared across all Airflow jobs, aka have secrets segregation. And then we had specific requirements. So security-wise, the segregation should be on Airflow job level. So when an Airflow job runs, it will have access only to its needed and restricted secrets. This is one. Second, tooling, we have HashiCorp Vault, let's use it. So secrets will be kept in HashiCorp Vault with ownership hierarchy, which is very important to understand, because the solution that I'm going to share here is based on that. So when I say ownership hierarchy, I mean that in Vault, whenever we create new secrets, we don't create it, in Vault, you have key values which are kept in a dictionary. So we had a high level dictionary of team, but you can choose to have products, for example, if you want to. So a team, and then inside the team, there's a project or sub-project, and then the key value dictionaries for that project. So that hierarchy was important for the solution that I'm going to share in a second. And the logic basically means that the secrets retrieval mechanism should be on server side. So we have Airflow side, the Airflow operators that I will cover in a second, and a secret service side, which was a service on my end, DevOps, that retrieved the actual secrets from Vault. So both of them are on server side and not client side. The solution, or here comes a secret service and secured operator. So solution was comprised of three components. First of all, Airflow secured operator. So Airflow was a tool that was maintained by a developer team. They maintained both the infrastructure and the operator. So they created a new operator for this purpose that the idea is to retrieve secrets for Airflow DAGs to use. So they created it, and this is the first component. Second component is secret service, a partner service that I created that retrieves the secrets for the Airflow secured operator from Vault. And third component is Vault. SecOps side manages the Vault as an infrastructure, but we, the DevOps team, manage the namespace for our department. Let's now go over each component separately. So Airflow secured operator, we have an Airflow DAG that wants to run. DAG is basically a job. Whenever a data engineer wants to have a new DAG or update an existing DAG and they know that they need secrets, the only thing that they need to do is import and use the secured operator to get the DAG secrets. That's it. That's the entire thing that is needed from the client side. Then the Airflow secured operator, what does it do? Two things: detect the ownership tag from the Airflow DAG, meaning if the Airflow DAG belongs to team backend X, then ownership tag is backend X. If it's frontend Y, then ownership tag is frontend Y. So that's that. And fetch the associated secrets from secret service. So Airflow secured operator approaches DevOps secret service, which authenticates Airflow as a client that is allowed to get secrets, and retrieve the ownership tags secrets from Vault. So Airflow says, hey, secret service, give me backend X secrets. DevOps secret service says, cool, here are the secrets of backend X, and returns them to Airflow secured operator. And then the Airflow DAG can continue. So they get the secrets via the secured operator, and the DAG can use the secrets and has the needed secrets to fulfill its operations. Secret service side, it is a Python service that exposes an API. Its purpose is to retrieve secrets for clients. First of all was Airflow client, but later on we utilized it for other clients as well. The input is app name and app key. It is basically implementing a naive authentication mechanism just to make it up and running, but later on we did think about implementing and integrating the company's authentication mechanism. So just for the sake of it, app name and app key to authenticate the client that approaches secret service, and then ownership tag. And then the output of the service is a dictionary of secrets owned by that ownership tag. So remember that the secrets in Vault are kept in an ownership hierarchy. This is the reason. Secret service flow. So let's go over the flow in the secret service itself. So step one, authentication handler, authenticate the client, Airflow, via app name, Airflow, and app key, which is a agreed upon token on Airflow side that the secret service knows about. Then get Teams Vault's credentials. So use the ownership tag to get relevant Teams Vault credentials, meaning Airflow provided the secret service backend X as an ownership tag. Then secret service approaches Vault to a specific secret called OT app roles map, and then it says, give me the app role ID and secret of backend X. Okay, because this is the key, app role a backend X, it is the ownership tag. So if it is in the map, in the dictionary, then I get the app role ID and secret of backend X. And then I authenticate with backend X app role ID and secret, get the Vault policies that are linked to the app role of backend X, parse the policies, and extract the paths from the policies. I will repeat that. I authenticate to the Vault using backend X app role ID and secret, get the Vault policies linked to the app role of backend X, parse the policies and extract the paths from the vault policies. And then I extract the secrets related to these paths. So I got the paths from step 3, and then I ask Vault, give me all the secrets that are in paths XYZ that I got from step 3. That's it, got the secrets, and then I return them to the secured operator as an encoding dictionary. Let's see the API as code. Again, I don't have much time to drill over really each bits and pieces, but this is the high level. So this is the code. Step 1, this is the authentication handler. So we get the app name and app key through a header on the API call. If it was authenticated, okay, from the designated function called auth handler, then we go to step 2, get team's vault credentials. So I pass the backend X on ownership tag to the get team creds function. If I got it, if it was in the dictionary, all good, then I proceed to the next level of get the secrets. This is a bundled of step 3 and 4. Here I authenticated with backend X app role ID and secret, get the vault policies, parse the vault policies, extract the paths, and get the secrets of these paths. So everything is in these 2 lines because it's one function that calls another. So there's that. And finally, return the secrets to the client, aka the secured operator. And all of the other stuff is for error handling. So this is for if I'm not able to get the team's vault credentials, I return an error. If the client didn't provide auth headers, then I return an error as well. And if the client is not authorized to get secrets, then I return a status code 403 plus an error. And the last part of the solution, HashiCorp Vault, as mentioned, secrets are kept in team's hierarchy. The ownership tag dictionary that I mentioned, that this is how I get the app role ID and secret of backend X of the ownership tag. The dictionary is managed by the DevOps team. SecOps manage the Vault as infrastructure, as a platform, and the DevOps team manage the department's namespace. So what did we achieve in this solution? Several things. So first of all, alignment and shared vision. So we were able to align to security requirement and cross infrastructure vision by leveraging HashiCorp Vault, because then we basically tapped into company vision, have one solution for all secrets management. Not all, but we started a trend and hopefully continue to other use cases as well. And basically leverage HashiCorp Vault for all secrets management scenarios. This is the shared vision that is now shared between the company and the department. Standardized secrets management. We were able to avoid unclarity of all data developers that didn't know how to get secrets for their Airflow jobs, define processes, and improve their velocity. And have self-service for secrets management, because after we set up and we had an initial setup of team onboarding, a new team that wants to onboard a Vault and use Vault as a secrets manager, then this team manage their own secrets. They can add new secrets, delete secrets, do whatever they want, and get them through their flows in Airflow. So that's the thing, self-service once the initial setup was done. And the way that I wasn't able to really drill down to how secret service work, but how the function in each part is designed is that it supports other use cases as well, and not only Airflow. So we were able to onboard more use cases in secret service, consolidate tools, and deprecate legacy implementations and migrate them to secret service. So I know I wasn't able to drill down much, but I hope it did open your minds and let you see how we can leverage intermediate solutions in order to retrieve granular secrets from HashiCorp Vault. If you have any questions, feel free to reach out. Thank you very much.
Thanks, Hila. That was awesome. You're really taking simplifying secret management to another level with Secret Service. I can totally see how it benefits others too. Now, HashiConf is right around the corner. Do you want to share something, Grim?
Yeah, but before we jump into that, it is true. Airflow, if you've ever used it, you know it's not a simple system. It is a powerful system, but making secrets and anything in Airflow user accessible and developer friendly is really, really hard. So congrats, Hilla. Beautiful solution. But yes, of course, we're only a couple months out. October 14th through 16th, all of us will be gathering in Boston for HashiConf. Super excited for that. You can get more information for that on hashiconf.com. Check out the sessions, do some certification workshops. There's so much to do that I can't even put all of that in the 2 minutes that we have for this segment. So I guess you'll just have to go there and register and meet us in Boston.
Yes. Awesome. So, chat, please welcome Max Fröhlich, who's going to talk about how you can make sure that nothing sneaks into your Nomad cluster, because everything gets checked using the Nomad admission control proxy and the Notary project. Take it away.
Hi there, and welcome to my talk, DevSecOpsify your Nomad deployments with the Nomad admission control proxy and the Notary project. I'm Max Fröhlich. I work as a platform engineer at Serviceware, where I help our developers to bring the application to life in Nomad. Therefore, we usually run Docker containers in Nomad. And this Nomad DevOps cycle looks a little bit like this, oversimplified. The developers build a Docker image, they push it to a registry, they take the version they just pushed to the registry and write it into the Nomad job file, then they submit it to this Nomad server, and everything comes to life. But what could possibly go wrong, right? Like this DevOps approach where everybody's allowed to deploy and run their own Nomad jobs is great, but what's actually inside those images, right? I mean, did your team build those images? Did they find it on the internet and just submitted it? Maybe you've checked the bill of materials and all the contents of that image. That's great, but the problem is also that image tags are mutable. So even though you may have validated them, somebody else may overwrite them later. Looking at this problem with the mutable tags, that means like every time Nomad decides to create a new allocation, you bear the risk that actually the content of the image may change and therefore the behavior. One solution to mitigate that issue is and to have more reproducible deployments to use instead of tags, you use the digest of that image. So that means if you look at your Nomad job, then instead of referencing the image with a tag, you're referencing it with the digest. But how could you enforce that? Because people may use this or not, but at one point you want to enforce that. Therefore, it's good to look at the concept of an admission controller, which comes from Kubernetes, and it's a kind of a piece of code that intercepts requests before they're actually sent to the server, and then do validation or even mutation on those. I have a small side project called the Nomad Admission Controller, which is something similar for Nomad. It's a small application that sits in front of your Nomad server API, intercepts all the job-related requests like plan or run, then runs it through several configurable processors, and mutate and validates them. How does this work? Nomad jobs are usually written in HCL, but if you submit them actually in the server in the background, they're first parsed into JSON and then sent, which makes them as a perfect candidate for the Open Policy Agent, which is a small rule engine you can embed in your application to that checks JSON for certain things. And we can use that for validation purposes to either create warnings or errors, and also use it for even use it for mutation, where you can create JSON patches that then modify the job itself. for the purpose of this video, we can only focus on the validation so far, for now. How does the validation work? In this case, for example, I'm going to produce errors that contain a list of errors that may contain the error forbidden image, which is added to the errors list for every task and every task group that has an image that is named Bitcoin miner, because we don't want to run Bitcoin miners in our cluster. So let's have a look at this demo. To get back to the problem of enforcing image digests, where we said we want to use, instead of tags, we want to use a digest. I prepared a small setup. I'm running a little Nomad cluster on my machine, and in front of the API, I'm running this my Nomad admission control proxy. And in my cloud, there's already a Docker registry deployed where I'm going to push an image to, and then later on submit a job file, which then tries to run my image. So in that demo, I'm going to build a small Docker image. It's based on an Alpine image. And the only thing it does, it adds an entry point that says, "Hello, HashiTalks secure friends," and then takes a nap for 1 hour. So I'm going to build this image now. Great, it's built. And then I'm going to push it to my registry. Great, it was pushed. So let's now try to run this Docker image. So first we're going to say nomad run demo.nomad. Oh, and I got an error. Apparently the enforced digest rule kicked in. So, but you see, here's the SHA I could use. And I'm going to reference this one and see if it works now. Yep. Makes it a bit more unreadable, but on the other hand, it improves security. Okay, let's see if this one works. Nomad run. Oh, and apparently it is deploying. Yay, great. So let's see. Here we see our demo application running. If we click in and go to the recent allocation, we should see in this allocation the demo running logs. It says, "Hello, HashiTalks secure friends." Great. So, but how did this rule look like? So therefore, let me go back to the code. And I registered this digest rule here. And you could see it says like the list of errors contains an error message. And this error message is produced by checking for any image. Input means the job file, which has like a text for any tasks here, which has a driver of Docker, and then takes the image, checks if the regex matches this, which means like does the image is referenced with the digest, and if this is not the case, I'm going to produce the error message where I'm going to say invalid image, and that's the image. Great. So now we enforced image digests in our Nomad job files, and therefore they're hopefully more deterministic and give us less surprises while they're running. Reproducible deployments are nice. The question is still, should we run those images at all? And we want to run them, but usually we want to scan them for vulnerabilities first, or at least make sure we track the software bill of materials. So in case we detect vulnerabilities in the future, we directly can point to the images that are problematic and need to be taken care of. therefore, we kind of want to also ensure that they're not only reproducible, but also kind of signed by a certain process that they're good to go. And therefore, the notary project, aka Notation, is a project that allows you to sign images after you may have run some security checks on those and mark them that they are okay for deployment. Usually you do this somewhere in your pipeline in a dedicated step maybe. The notary project describes this for the Kubernetes workflow like here. The developers build and push their Docker images. Then notary is used to sign those images. The signature is attached to the image and pushed to the registry. And in the deployment during the deployment phase, the Kubernetes admission controller verifies that signature, and if it's okay, the app is good for deployment. The cool thing is that the notation library is a Go library you can easily include in any kind of project you like, and especially the open policy agent is there a perfect candidate, as you can extend the functions that are available in the rules very easily. And these two technologies combined allow now the Nomad admission control proxy to do image validation before Nomad jobs are deployed. And therefore, I want to give you a short demo of image signing and verification in Nomad. For this, let's head back to our last demo. And the very first thing we're actually going to do is stop the current running job, saying Nomad stop -purge demo. Great, so removed it again. And now I'm going to activate the second rule we defined. I go to my Nomad admission control configuration, and I'm going to enable another validator for that case, where I'm going to reference this notation rule. And now, if I'm going to try to, I'm going to restart my admission control proxy. And now, if I'm going to try to redeploy it again, come on, Nomad run demo.nomad, I get an error. And apparently the image could not be verified. So how did this happen? If you look now at this second rule we just enabled, you can see it starts similar. We define a list of errors, and those contain a message which is defined down here, and it's defined when the Nomad job image has in it one of its task groups, a task with a driver's Docker, and then we're going to take the image from the config of the task, and we put it in our custom new built-in function called notation verify image. This will return true or false, either if the image is valid or not. And if it's not valid, we're going to produce this error message where we say task group and task image cannot be verified, which matches this error here we got when we tried to deploy it. Great, so it's time to sign our image. So I'm going to copy the image reference here, and this new terminal will act as my pipeline that does this signing. And for that, before I'm going to sign it, I want to first check if it's actually okay and there's no security vulnerabilities inside. So I'm going to use Gripe here. That's one of the tools that allow you to scan your image and see if there are any vulnerabilities in there. So it's scanning. Apparently it also found some issues, but it looks like they're all medium. So medium is fine for me, as long as there are no high or critical findings. So now I'm going to take a notation and say, please sign me that Docker image, and it was successfully signed. So we have the signed image now. Let's try to rerun that part, and we see no error, and the image is being deployed. We can head already over maybe to the Nomad UI, and we can see here's the new version running, and if we look here, it says, hello HashiTalks Secure Friends. Great. So now our Nomad jobs are more reproducible and secure, and we made sure by enforcing first digest that the image is always the same, and with the signing process of Notary, we made sure that only images that jump through certain security hoops are marked as okay for deployment, and no other image can sneak in our cluster. So thank you very much for listening to my talk about my little side project. Check it out under the GitHub link above. There's another video where I show also the capability to mutate Nomad jobs. Check out the YouTube link below. And thank you very much, and enjoy the other talks.
Always love these HashiTalks talks where people go like, oh, check out my little side project, as if it's like, you know, a 5-line script or something, when in fact it's actually a very thought through and very well-defined, you know, solution to a problem that many of us run into. Image signing is very important. I wish you could see Bruno's laptop right now. He's got so many notary stickers on there. Last count, I think we had 3 different ones. So, you know, like if you like stickers, Bruno is definitely a person to talk to. You might notice, though, that Bruno is not here right now. That's because this is HashiTalks Secure, and I revoked his access token. But we'll generate a new one for later. For now, we're going to head to our next speaker, and we're going to talk about something that just rolls off the tongue. The European Network and Information Security Directive, aka NIS2, is a directive to raise the bar for information security. And if you're doing anything with infrastructure, you know this is going to affect you. It will affect your company, it will affect the way your company deploys, how it handles infrastructure, and all the processes and protocols and everything. So with that, let's head on over to Cedric to talk about fortressing the critical stuff, achieving NIS2 compliance with HashiCorp Vault and Boundary.
Hello everyone, and welcome to the HashiCorp Secure Conference. Today, I'm thrilled to discuss the upcoming NIS2 directive and how HashiCorp Vault, Consul and Boundary empower you to achieve compliance through Zero Trust security principles. First, let me introduce myself. My name is Cedric Derue. I'm a cloud architect, programmer, trainer, speaker, and published author. Since 2006, I have worked as a professional consultant for Altron Technologies, now Capgemini Engineering, expert in cloud technologies, particularly the Microsoft Azure Cloud. I often advise in the banking, pharmaceutical, energy, and industry sectors. I collaborate regularly with Microsoft through the LinkedIn Learning platform and my contributions as Microsoft MVP. Finally, I'm passionate about HashiCorp solutions, and I often use them for cloud infrastructure automation, and I have been recently awarded HashiCorp Ambassador. So, this is the agenda. First, we will dive into the history of NIS, exploring its foundations. Understanding the path we have traveled is key to appreciating the advancements brought by its successor, NIS2. Next, we will dissect the improvements NIS2 offers over NIS1. This includes a deep dive into the articles number 20 and 21.2, unpacking the specific regulations that impact your organization. But who exactly is affected by NIS2? We identify the actors who need to prioritize compliance, ensuring you understand where you stand. To continue, you will explore how a zero trust approach empowers you to achieve both regulatory adherence and a more robust security posture. So the benefits of zero trust are undeniable, and we will underline the advantages this approach offers, making your systems more resilient against modern threats. To fortify your zero trust strategy, we will dive into identity-driven component. This crucial element establishes a foundation for granular access control. Finally, we will culminate with a 6-step roadmap for implementing zero trust security. This actionable plan will equip you with the tool and knowledge to build a secure and compliant future for your networks and your information systems. So, buckle up and get ready to explore the exciting world of NIS2 and zero trust security. The French National Cybersecurity Agency paints a concerning picture in its 2023 cyber threats overview. With geopolitical tensions escalating and France hosting international events, cyber threats are on the rise. Attackers are evolving their tactics and exploiting vulnerabilities relentlessly. In this ever-shifting landscape, the agency emphasizes the critical need for organizations to strengthen their defenses by implementing even the most basic cybersecurity recommendations. That's why the NIS directive is a crucial step towards improving the European Union cybersecurity resilience and preparedness. Here it is, the history of the NIS directive from NIS 1 to NIS 2. On 2016, the NIS 1 directive is adopted by the European Parliament and the European Union Council. 4 years later, in 2020, the European Commission proposed the NIS 2 directive. In 2021, NIS 2 negotiation began among the European Union institutions. In 2022, political agreements are reached on NIS 2 provisions. And at the end, this year, in 2024, NIS 2 directive is expected to be fully implemented. So, cyber threats are more sophisticated and the attack surface has expanded significantly. To address these challenges, NIS 2 represents a significant evolution of the original directive, NIS 1, by filling some gaps. NIS 2 addresses this gap by, firstly, broadening the scope of regulated entities. More organizations now fall under its umbrella, ensuring a wider net of protection. Secondly, mandating stronger security measures. NIS 2 outlines stricter requirements for risk management, incident reporting, and supply chain security. Thirdly, enhancing enforcement mechanism. Tougher penalties for non-compliance ensure a more robust security landscape. With this enhanced framework, NIS 2 aims to make the European Union a more resilient digital environment. The article number 20 of the NIS2 directive focuses on governance and staff training for cybersecurity within essential and important entities. This article underlines that the management bodies of these entities must approve and oversee the implementation of cybersecurity risk management measures as outlined in the article number 21. The article number 20 insists also on training requirements. The goal is to equip essential and important entities with the knowledge and skills to identify risk, assess cybersecurity practices, and understand the impact on their services. The article number 21.2 of the NIS2 directive dives into the specific cybersecurity risk management measures that essential and important entities must take. Later, we will explain what are essential and important entities. So this article emphasizes a comprehensive approach to securing network and information systems. The measures adopted should address various threats and vulnerabilities, not just focus on a single type of cyber attack. So, the directive mandates at least 10 specific measures, including risk analysis and information security policies. This establishes a framework for identifying and mitigating security risk. Next, incident handling, a plan for detecting, reporting, and responding to security incidents effectively. Next, business continuity, measures like backup management and disaster recovery to ensure continued operation during disruptions. Next, supply chain security, addressing security risk associated with vendors and service providers. However, while 10 minimum measures are outlined, the implementation should be proportionated to the entity size, sector, and the potential impact of a security incident. Now, let's dissect the key change impacting affected sector. NIS1 focused on sectors like energy, transport, and finance. NIS2 casts a wider net, encompassing entirely new industries. This includes the postal, waste, and manufacturing sectors. We can notice also that the NIS2 directive introduces a two-tiered approach beyond sectors. Now we have essential entities and important entities that we make mention just before. On the one part, essential entities face the most stringent regulations. They represent sectors deemed highly critical to societal functions. Think energy grids, air traffic control, and hospitals. On the other part, important entities encompass a broader range of organizations, including waste management, manufacturers of critical equipment, and online platforms. The compliance requirements for important entities, for these entities, are less onerous, reflecting their varying risk profiles. NIS2 strongly positions Zero Trust principle as a cornerstone for achieving compliance. Here it is why. Focus on never trust, always verify. Zero Trust aligns perfectly with NIS2 emphasis on assuming breach and constantly verify user and device access regardless of location. Next, NIS2 basic cyber hygiene measures like multi-factor authentication and least privilege access control, central to Zero Trust, directly contribute to meeting NIS2 baseline security requirements. Next, continuous monitoring. Zero Trust promotes continuously monitoring and verifying all activity across your organizations, systems, and device in real time. This creates a safety net constantly on the lookout for threats. So, by adopting Zero Trust, organizations can demonstrate a proactive approach to cybersecurity, making NIS2 compliance more achievable. Zero Trust security offers a layered shield against cyber threats, constantly verifying user identities and device trustworthiness before granting access to systems and data. This never trust, always verify approach minimizes the attack surface by eliminating implicit trust within the network. Even if a bad actor breaches the perimeter, they will still face hurdles to reach sensitive information. This translates to reduced data breaches, stronger compliance postures, and ultimately an organization that is more resilient in the face of ever-evolving cyber threats. Now, let's talk about Zero Trust security and identity-driven controls. Zero Trust eliminates implicit threats and continuously validates every access request. This never trust, always verify approach perfectly aligns with the needs of the NIS2 directive. HashiCorp offers a comprehensive suite of tools to build a robust Zero Trust architecture with three solutions playing a vital role: HashiCorp Vault, HashiCorp Consul, and HashiCorp Boundary. HashiCorp Vault secures sensitive data and enforces least privilege access. But it goes beyond just passwords. Vault can also be leveraged for machine authentication and authorization. Imagine you want a secure way for machines to prove their identity and what they authorize to do. HashiCorp Vault facilitates this machine-centric identity and access control. Next, HashiCorp Boundary provides secure access to privileged accounts and resources. Boundary acts as the gatekeeper, ensuring only authorized users can access designated machines, eliminating the risk of unauthorized access or lateral movement. Next, HashiCorp Consul secures HashiCorp Consul secures machine-to-machine communication by enforcing application authentication and ensuring only authorized devices can interact. It automates identity-based access control, encrypts traffic, and codifies authorization rules, all for scalable, efficient, and secure service discovery, network configuration, and connectivity across any cloud or runtime environment. And finally, we have a fourth component that is the SSO MFA component. SSO and MFA work in tandem to ensure secure access. SSO streamlines logging by allowing users to access multiple applications with a single credentials. MFA adds an extra layer of security by requiring a second verification factor like a code from a phone app beyond just a password. This two-pronged approach makes it significantly harder for unauthorized users to gain access, even if they steal a password. As a conclusion, NIS2 compliance is not just a regulatory hurdle, it's an opportunity to strengthen your security posture. By adopting zero trust principles with HashiCorp Vault, Consul, and Boundary, you can achieve compliance while enhancing your overall security ecosystem. Remember, zero trust is a journey, not a destination. HashiCorp offers the tools and resources to help you get started and stay ahead of the ever-evolving threats landscape. So, visit the HashiCorp website to learn more about Vault, Boundary, and Consul, and explore free trials to jumpstart your Zero Trust journey. Thank you.
Phew, I managed to get a new access token.
I mean, I noticed you were logging in from an unapproved network, so I just had to revoke it. That's how security works, my man.
Nice. All right. Thank you very much, Cedric. Making legal things sound this easy is truly a gift. I personally wasn't aware of all the details of the NIS2 compliance requirements. It's also great to learn how Vault and Boundary address those. But next up is Jacob and James. I'm very excited about their talk, and I don't want to spoil too much, but it will be about certificate management using Let's Encrypt and Vault. Chat, please give them a warm welcome.
Automating TLS certificate management using Certificate Manager and HashiCorp Vault. My name is Jacob, and I'm a Senior Systems Engineer at Quantcast.
Hi, my name's James, and I'm also a Senior Systems Engineer at Quantcast.
Quantcast is an American AI-driven real-time advertising tech company. Our agenda for today covers all topics listed on this slide, and we'll go into more detail on the respective slides.
Hi, so to start things off, our presentation revolves around rotating certificates at Quantcast and how we changed systems in place that we previously had. So to start things off, at Quantcast, similar to many other technology companies, we have a wide variety of use cases for issuing and using certificates in our systems. To give some more direct reference to this, we use certificates through AWS Cert Manager directly for AWS load balancers. Additionally, we often need certificates directly on our systems for other reverse proxy solutions. Very often, we use certificates for mutual TLS authentication as well. We frequently use Vault's PKI secret engine for that with imported CAs. And also for auditability and role-based access control, specifically using those API integrations with Vault make that very easy for us. So although nothing was inherently broken with our previous methods of handling certificate issuance and retrieval at our company, there was a lot of improvements that could be made. And occasionally we'd experience some incidents related to certificate rotation or certificate expiration. Some domains were issued by hand due to organization validation being used, which was later figured not to be an explicit requirement. We used multiple certificate authorities with teams rolling their own certificate issuance means, creating kind of a lack of homogeneity in that space. Also, as well, costly multi-domain certificates and costly organization validation with certificate authorities charging a lot just for an additional SAN, for instance. And as well as there'd be a relatively infrequent annual rotation cycle where institutional knowledge could potentially be lost in the course of that time frame. So yeah, this slide is very much a tongue-in-cheek. There wasn't this much complexity or messiness in our setup, but there was a lot of folks reinventing the wheel and rolling their own retrieval methods as well as their own issuance methods for certificates. This lack of standardization also left a policy management involved a real headache to work with. Multiple CAs were being used with, in some cases, manual validation and a lack of just standardized monitoring around those processes. So Yeah, needless to say, it wasn't a great situation, although it is a bit of an exaggeration for that slide. So enter Certificate Manager, a Kubernetes service that solved a lot of problems for us in this area. Cert Manager has custom resources that can link up with virtually any trusted certificate authority, and as well as Vault for internal for internal certificate issuance through automated challenges. For instance, there's an Acme integration that can use DNS challenges, as well as Vault, which can use a variety of authentication means with Vault. For a particular setup, we use Kubernetes authentication roles, which work great and are very secure. We also put some toolings such as Terraform to manage cluster issuer resources for Cert Manager, which was also very convenient. So here's a high-level overview of how we leverage Certificate Manager for certificate issuance at our company. We have cluster issuers primarily for Let's Encrypt for Vault and Let's Encrypt and Vault for all domains that we care for. The cluster issuer support for Vault's PKI engine was very easy to configure with Kubernetes authentication role and provides us with a lot of continued utility in the space. The Acme configuration additionally worked excellent for Let's Encrypt and uses Kubernetes service accounts with AWS IAM access, so we can facilitate making those challenge records easily and securely. After issuance, a job pulls our Kubernetes secret store and ships them to Vault and AWS Cert Manager to be used in various integrations. Some of these might be via Argo CD's Vault plugin or through just general access through Cert Manager as well. These certificates get issued. So so for the certificate reissuance process, certificates are renewed automatically at 2/3 of their certificate lifetime, if for just default parameters. So since we're using Let's Encrypt, this changed from a staggering annual rotation to a rotation of every 60 days, which enforced a lot of automation around the process. And as well as a scheduled cron job that checks for certificate drift in Vault and AWS Certificate Manager. Also, this cron job, where applicable, updates values to match Kubernetes secret stores and emits Slack notifications of actions taken. So we're always informed of when a rotation occurs. And as well as that, perhaps most importantly, it puts all certificates in the Vault secret store in a path that is very organized per domain. So all services downstream that need to reach out to them can retrieve them in a systematic manner. And without further ado, I'm going to hand things off to Jacob to continue the rest of the presentation. Thank you very much.
Hi. So for certificate audit and observability, we use Datadog metrics and alerts, and we base those primarily off of AWS ACM entries. It's a very useful heuristic way to look at expiration times and get data points that give us more information about what's going on and why. The system is pretty predictable, and we've configured our alerts in such a way that if something doesn't behave in a desirable, predictable manner, such as a certificate fails to renew, we're going to get a paging event well before that certificate would be a problem if it were to expire. In the case of, like, let's say a certificate's going to expire in 30 days, we're going to, if for whatever reason we have not renewed it, let's say 20 days in, we would get a page and we would have 20 days to rectify the problem. So it's our alerting does a pretty good job about keeping us in the know about what's going on in a predictable and consistent manner. We're also able to use the certificate transparency logs to make our metrics a little bit more granular in terms of what we're feeding into Datadog. For the migration process to from our legacy lack of consistency to where we are now, the primary tools that we leverage is Argo CD's Vault plugin. Allows us to make Kubernetes secret. Allows us to use Kubernetes services with Helm templating for inline secret configuration, allowing us to reference the desirable payloads from Vault. We can use the Vault agent injector, which is a Kubernetes sidecar that runs along with a container and is able to be updated as needed. And then all integrations use dynamic authentication methods against Vault to read the certificate payload data securely. Some of the issues we ran into in our migration process is that some of the more legacy systems did not have the current certificate root for Let's Encrypt. For a custom CA, we already knew that we were going to have to make the root available in the CA chain, and that was a little bit of a more predictable issue. For the case of Let's Encrypt, we did have to work with teams on a case-by-case basis to make sure that the CA chains for the respective services was able to be set correctly so that we could have some assurance that the certificate would be able to continue to work as intended. One of the components of this project is that because the Let's Encrypt issued certificates have a significantly shorter lifetime in the form of 90 days versus 365, automation became absolutely mandatory. In the case of getting teams to migrate to using whatever their previous deployment method was, did require some understanding of what their existing deployment method, whether it be by hand or some form of automation, and then being able to work with them to use a more consistent and predictable manner. For the case of Kubernetes services that used the Vault Agent Injector, because of the way that persistent storage is handled in Kubernetes, when you are referencing a secret from Vault, that secret is secret's immutable, and so you need a service like Reloader to be able to tell the pod to restart and get the updated Vault payload. Once we implemented Reloader, we were able to resolve this issue in a predictable manner, and that's something you can just bake into all of your pods. And accounting for cases where tools like Reloader were absolutely necessary, and they did take a bit more time, but it got us to a better end result. Using our new system, some of the advantages we've gained are that all of our certificates are deployed and renewed automatically without any human intervention whatsoever. As mentioned previously, we do have alerting in the event that something does not behave as predicted, but we have yet to run into a situation where we actually trip any of our monitors because of something working inadvertently, which is pretty nice. We use version control through GitHub to request a new certificate or to alter in any way, shape, or form what the certificate request is, such as if we add new SANs to a certificate, we can actually update our system in such a way where we'll replace the existing one in all the correct places. The shorter certificate lifetime of secrets, even though it does require automation to work, does equate to a better security set of practices. And in the long term, that's probably better for us as an organization. And Let's Encrypt being free gave us a sizable cost reduction year over year and has almost no operational cost to maintain within Kubernetes. Some of the lessons we learned from this project were that accounting for organizational resistance to change when implementing automation at scale is a must. Standardization around automation, once implemented, does reduce the possibility of replacement-based incidents quite a bit. And your most likely case of having an incident related to it when you do a system like we did is to actually not use the system at all in a given case. So as we get more services onboarded and make this a more universal setup, we're expecting to see next to no problems when it comes to certificate replacements. Enforcing frequent rotation via automation does also expose misconfigurations within a given service that may very well not have ever been noticed. And when you're doing changes like this at scale, and you do see a problem, you do have to fix it or work with the respective teams who maintain said service, but it is something that is a worthwhile audit exercise for any kind of organization at scale. For any questions, feel free to direct them further, and we will proceed from there. Thank you for your time.
Thank you so much for joining. Bye.
Certificate management is never easy. I love it when people have actually thought out solutions that you can more or less apply to your use case, make it easier for teams to onboard, and not actually worry that 88 days down the road, you are going to be left with a broken certificate chain. This is absolutely solid. Moving from certificates to something more fun, well, more fun in the sense that less stressful possibly. I'm curious, we talked a little bit about, we've got speakers from all over the world, but what about our audience? Where are you from? Give us a city, tell us where you're from, if you feel like it, because we'd really like to know. And of course, we'll pick a winner from one of the cities that's been mentioned to get some swag from our swag store. Might get a t-shirt, cups. What else do we have? Fanny packs, I think. Don't know what else. Plenty of other things.
Awesome. So, chat, please also join me in welcoming our next speaker, Matthias Fjellström, who will show us how to set up HTTP Boundary using Terraform the right way.
Hi, welcome to my talk on unlocking privileged access management, HCP Boundary with Terraform. My name is Matthias Fjellström. I'm a cloud architect consultant working at Solidify. This is my second year as a HashiCorp ambassador, and I'm also a user group leader for the user group, HashiCorp user group in Gothenburg, or Göteborg, as we say in Sweden. So, Boundary. I expected you know a little bit about Boundary to be able to follow along my presentation, but this is at a high level what HashiCorp Boundary is. So this is a copy-paste from the documentation. Basically, Boundary is an identity-aware proxy aimed at simplifying and securing least privileged access to cloud infrastructure. So at a very high level, we have some sort of trusted identities, and through the use of Boundary, these identities will be able to access basically anything with a network address. So Boundary is sort of tech agnostic, so it doesn't care if your resources are running in AWS, in Azure or GCP or wherever it might be. But for a demo, we need to pick some sort of tech stack to work with. So I will be using the community edition of Terraform. I will be using the managed versions of Boundary and Vault in the HashiCorp Cloud Platform. I am using AWS for all of my cloud resources, and I'm using Microsoft Entra ID as my identity provider. And finally, I will be using GitHub to highlight sort of a use case for Boundary. All right, the infrastructure we will be looking at looks like this. So on the left, I have my HashiCorp Cloud Platform organization with Boundary and Vault. And on the right, I have my VPC running in AWS. I have two subnets, one public and one private. I have a Boundary worker in each of the subnets. And in the private subnet, I have two types of targets that we will access. So one is an EC2 instance, and the other is RDS Aurora cluster, basically. I have set up private peering between my virtual network in HashiCorp Cloud Platform and my VPC in AWS. And this allows for private communication with Vault. All right, so we will be looking at a lot of Terraform code. We'll briefly look at some Go SDK code, and finally a little bit with the Boundary CLI in GitHub. So mainly we will focus on how you configure Boundary using Terraform. There is a lot of code, so I won't be able to go through everything, but I will provide links for the GitHub repository for later. So specifically, we'll be looking at scopes, auth methods, users, groups, roles, etc. We'll spend some time looking at workers. Then we move on to host catalogs, host sets, hosts, and credential stores and credential libraries. And finally, we'll be looking at targets and aliases. We'll also see how you can use the Go SDK and the Boundary CLI for two different automation scenarios. So let's jump to Visual Studio Code to take a look at my Terraform configuration. So I split it up in 2 different directories. In the first directory, I have my HCP resources and some AWS networking resources. Let's just look at specifically what's important for Boundary on the HashiCorp Cloud Platform. And it's this resource. It's fairly simple to configure. I give it an ID. I provide an initial username and a password. I specify what service tier I want. I'm using the plus tier here just to be able to use all of the features that are available. I'm configuring a maintenance window for my cluster. So this is whenever updates of my cluster could happen. So that's basically it. Below here, I configure a virtual network and a Vault cluster as well, but we won't spend time looking at that. My second directory contains more of the actual Boundary resources. So first of all, if I just scroll down and look at my providers, of course I have my Boundary provider, and I've configured it down here. I need to provide the address and the auth method login name and password. Once that is done, I can start configuring resources. So one of the first things you will configure in Boundary is scopes. So in Boundary, you can configure resources into various scopes. So at the top of the hierarchy, you have the global scope. Inside of the global scope, you can create organizations. That's what I'm doing here. So I create an organization called HashiTalks Secure 2024 organization. And inside of my organization, I create a project called AWS Resources. I have a few other scopes down here as well, but these are mostly for illustrative purposes, just to illustrate how you can configure or organize different scopes. So you can take a look at that on your own time. Once we have a scope set up, it's natural to want to set up a method for your users to sign in. So you can use the password auth method that comes along with your HCP cluster, or you could use the configure your own OIDC provider. And that's what I've done here. I configured one for my Entra ID tenant. I'm placing it in a specific scope, so I'm configuring it for my project scope. And I'm specifying it's the primary for the scope. And then I have a number of OIDC specific configuration here. Most importantly, I have the client ID and the client secret, and these come from my Azure AD or Entra ID configuration. If you're interested what that looks like, I have a file down here called Entra ID, so you can take a look at how you can configure Entra ID for this. All right, so we have our scopes, we have our auth methods. The next thing we might want to do is start configuring a few roles. So a role in Boundary is exactly what you might think it is. So it configures the sort of permissions that users and groups have. And permissions are provided in these sort of grant strings. So we won't spend time learning about these. The documentation is excellent. I suggest you go read about grant strings. But I have a few roles set up. I have one reader role, which I assign to everybody. I have an EC2 role specifically for accessing my EC2 instance targets. Currently, I haven't assigned anybody to this role. Likewise, I have roles set up for accessing my Postgres database, but here as well, I haven't assigned any principal. So we will be doing this later with the Boundary CLI. I have a few more roles, but most importantly is that if you have some sort of automation account, for instance, you want to automate certain stuff in a Boundary using, for instance, GitHub or an AWS Lambda, then you most likely want to set up users and roles for those automation accounts. So that's what I've done here. I have a role for Lambda, I have a role for GitHub, so they are allowed to do certain sort of automation tasks. Let's jump into managed groups. So a group is just a collection of users. A managed group is a group that actually exists inside of your identity provider. So I have groups inside of Entra ID, and the managed group is basically the corresponding group in Boundary. So whenever a user from one of my Entra ID groups signs in, it will be assigned to one of these Boundary managed groups. So groups are, of course, a great way to assign permissions instead of assigning permissions directly to users. All right, so moving on, let's jump immediately to workers. So workers are sort of the second main piece of boundary. We have the boundary control plane, and you have boundary workers. So I have 2 workers. I mentioned I have one in the public subnet and one in the private subnet. So let's just look at the public worker. First of all, I configure some networking permissions so it will be able to communicate with what it needs to communicate with, and other things that need to communicate with the worker is able to do so. So you can look through these security group rules, what is required. But most importantly here is I have set up a module for instantiating a worker. So what that looks like, let's open up the module. Basically, you create a boundary worker resource, very easy to configure. But then you need to create the boundary worker configuration, which is an HCL file. I'm using this template file function with this template. So you can look through this. This is basically HCL with some Go syntax language included. Next, I will be running the boundary worker as a service, so I configure a service configuration file. I will be writing this file to the instance using this cloud init configuration. I'm installing boundary and so on. So there are a lot of details here, but let's just scroll past everything. Finally, I create the AWS instance. So this is the actual worker. It's running on an EC2 instance in AWS. The private worker looks almost identical, so we won't have to go through it in detail. All right, let's move on. So once we have like all the basics set up and we have our worker set up, the next step is to start thinking about what we want to access. And this is where hosts come in. So let's focus on the EC2 host. So in this case, I'm creating a host catalog for my EC2 instances. A host catalog can be either static or dynamic. So in this case, it's a static catalog, which means I specifically add hosts that I define like statically. Dynamic host could be like where Boundary actually discovers hosts based on tags in AWS in this case. I create my actual host where I point to the private IP of my EC2 instance. And next I have a host set. So you can group similar hosts into a host set. In this case, I have a single host, but still I use a host set just to show you that this resource exists. So think of a sort of an auto-scaling group where all of the instances are identical. These are perfect to place in a host set. We have our hosts. We also need, or most likely will need, credentials to be able to access our resources. So this is where credential stores come in. And the most important resource to focus on here is the Vault credential store. So here I configure like how can Boundary communicate with my Vault instance. And once that is set up, I can configure credential libraries. So a credential store can contain one or more credential libraries. And a credential library is basically, it outputs credentials with the same access rights. So for a given credential library, all the credentials coming out from there will have the same sort of access rights. So in this case, I have SSH certificates coming out of this credential library. So the details here are fairly straightforward once you learn how it works. You can look through this on your own time. I also have credential stores for Postgres for producing read and write access to my Postgres database. All right, the final piece of the puzzle is the actual targets. So once you have credentials and you have hosts, you can combine these pieces into something called a target. So a target is basically what I said. It's the combination of one or more hosts, injected credentials, broker credentials, and a port to connect to. So this is what makes up a target. So in this case, I have a target for an EC2 instance. It will be pointing to my EC2 host set. It will use the SSH injected credentials that we looked at briefly. It will also use some broker credentials. We won't spend time looking at these, but it's good to know that you can have sort of simple JSON credentials that you just inject that the user might need for some reason. The difference between injected and broker credentials is basically that injected credentials are never visible to the user, while broker credentials will be visible to the user. Here I have a boundary alias. So this is a new resource which came with boundary 0.16. So this allows the user to just specify this simple value when it wants to connect to a target instead of having to like find out the ID of the target and then connect to that. So that's basically all the details we need to look at the moment. A lot of details, of course. You need to spend some time looking through this to really understand what's going on. Right, so let's just spend some time looking in the boundary admin UI. So here I have signed in with my admin account. And this is the first screen I can see. I can list all of my organizations. So I have a few organizations. The most important one is the HashiTalks Secure 2024 organization. We can see that I have session recordings. So these are whenever somebody signs into an SSH type of session, it will be recorded. So we can take a look if we want to. Session recordings are stored in storage buckets. So you can see how this is configured in the code. I didn't show it, but you can take a look on your own. You can have storage policies, which basically configures how long should storage session recordings be stored. I have aliases. So this is where I can see the aliases I've set up and what target it points to. I can see my workers. So I have my private and my public worker, and I have two HCP managed workers. So this is kind of interesting to know that when you set up HCP boundary, you get two workers, which you can use for accessing any publicly available targets that you might have. I can see my users. So I have my AWS Lambda admin account. This is an automation account. We didn't look at it, but it's there. I have my GitHub automation account. I have the admin user that I've set up together with HCP boundary. And there are some users that also comes along. I can see groups. So I have a group set up for my automation users. I see that I have two members, my Lambda function and my GitHub account. I can see my roles. So here, for instance, I see my GitHub automation role. I can see what principals are assigned to it, and I can see what grants are included in this role. Under auth methods, I see the password auth method. So this comes along with your new boundary cluster for free. And this is what allows you to sign in using the admin user to start with. If I go to organizations and I click on my organization, we see that I can click on auth methods. And here I see enter ID. So this was the enter ID OIDC type of method I set up. Likewise, I could have different roles in this stage. I can have other groups and I can have other users. And here I see I have two users set up. So these are users actually existing in my enter ID tenant. We see that I could have different storage policies for this organization, which basically means that, for instance, you might have one organization where you would like to keep the recordings for a long time, while in a different test organization, you might not want to store it more than a day, for instance. If I go to projects, I see that I have 3 projects in this organization, one called Azure resources, one AWS resources, and GCP resources. I open up my AWS resources, and inside of here, I can see if there are any active sessions. Currently, there are no sessions. I can see all the targets that are available here. I have three targets. I can see my host catalogs, my credential stores, groups, and roles. Let's go back to my organization. There was one thing I forgot to show you. If I go to my auth methods and I click into enter ID, I can see managed groups. So these are the managed groups which are reflected from my enter ID tenant. So I have one on-call group and one all users. So whenever a user belonging to, for instance, the on-call group signs in, it will be automatically associated with this corresponding managed group inside of Boundary. So let's jump now to how is this, what does it look like in practice? So this is the Boundary client running on my Mac. So let's just sign in with a user. I will begin by signing in with the admin user. So this is just to be able to show you everything, all the targets available. So the targets are loading here. We see I have 3 different targets. I can click connect on my EC2 instance and the connection will be set up. And if I go to the shell tab here, we see that I can connect to this specific target. So now I am inside of my EC2 instance. I didn't see any credentials. I didn't need to know anything exactly where the instance is running. I was just able to simply connect to it. So end session. So I will sign out and we'll look at a different example. So let me just make sure I am in the correct user. I choose a different scope to sign into. So in this case, I choose my organization scope. This is where I configure my Enter ID authentication. So if I click sign in, now you won't be able to see the sign in box, but I'm picking one of my user called Lane Buck window. And authentication was successful. So when the user is signed in here, we see that no targets are available. So in this case, this user has no specific permissions inside of Boundary. So I will illustrate how you can provide your users with access. So there are a number of ways of doing this, of course. In this case, I have set up sort of an issue ops approach. So now I'm signed into my GitHub organization with my user Lane Buck window. I can go to issues inside of my repo and then click on a new issue. Now I configured an issue template called Boundary Access Request. So click on Get Started. I say that I give it a title, EC2. I want to access this EC2 instance. I provide a reason because I want to access it for 3 hours. And submit new issue. All right, so an issue has been submitted. And if I go to my admin user, I can see the access request over here. I can open it up. All right, looks good. Let's go to actions. We see that an action has been triggered. And we see that Lane Buck window request your review to deploy the Boundary. So I can review, I can approve and deploy. So this only an admin user would be able to do, or you can just allow it out of the box if it's nothing sensitive. Going back to a Lane Buck window, we see that the issue is still open. If I look at the actions, we see that it's running. So it goes through a number of steps. And there it's done. If I go back to my issue now, we see that the GitHub bot has been commenting here that access has been granted. All right, what does that mean? If I go to my Boundary instance or my Boundary client and I refresh, we see that now I have access to this EC2 instance. So I can click on connect. And I can click on the shell tab and we see that now Lane Buck window was able to access the machine as well. Okay, so that's one way of doing it. And to remove the access, once the user, either the time has expired, I have an automatic cleanup to remove the access, or I can just close the issue. If I close the issue, we can see that another action is triggered. And this action will basically do the reverse work, so it will remove the access that was granted. All right, so that was basically how you can use the Boundary CLI. Of course, you didn't see that it was the CLI. Let's look at the workflow. So this was when I created an issue, this workflow was triggered. That's the trigger when a new issue is opened. And the most important step here is the configure access step. So we can take a look at here. We see that I'm using the Boundary CLI to make a number of requests. So I'm just fetching the correct user ID, I'm fetching the correct role to assign the user to, and then I'm adding a principal to this role. And once that is done, I'm posting a comment. So this is one way to use the Boundary CLI for automation. I also mentioned that you can use the Boundary SDK, the Go SDK. So I have another use case here. We won't have time to go through how it works. But basically, I have an alarm in AWS, and whenever that alarm is triggered, I will assign access to targets for my on-call group. So imagine that there's some issue with an EC2 instance, for instance, an alarm goes off, and then the on-call group is assigned access to be able to look at what's going wrong. So in this case, I'm using the Go Boundary API. So this is excellent support for working with boundaries. You can do all sorts of automation scenarios. So whenever an alert is triggered, I'm calling this assign on-call role function, which basically just fetches the principal ID for the principal. In this case is a group in Boundary, and it's adding this principal to a given role. So you can do all sorts of things with this. So take a look at the source code in the GitHub repository to find out how this works in practice. All right, that was sort of a hurricane of information. So what did we actually learn here? Well, you will need to spend some time going through this code on your own, but what you will notice is that configuring Boundary with Terraform is fairly straightforward. Once you have all the basics set up, there will be some sort of general workflow for new targets, and this is like no matter where your targets are running, so if it's in AWS or Azure or whatever. First, you will configure the target resource, so this might be setting up a new EC2 instance, setting up a new database, or setting up a Kubernetes cluster, for instance. Then you will configure the required boundary resources. So most likely you will need to add host catalogs, host sets, hosts, targets, roles, etc. And you most likely will need to add like configuring credential injection or brokering with Vault. So this will require some configuration in Vault as well. All right, so as I said, it was a whirlwind of information. But I suggest you go to this first QR code. It will be taken to the GitHub repository where you can see all of the details. And if you have any questions, feel free to reach out to me directly on LinkedIn. You can visit my blog. I write a lot about Terraform, Boundary, Vault, and other interesting topics. And if you're based in the Gothenburg area, feel free to join the HashiCorp user group. And this goes even if you're outside of the Gothenburg area. Feel free to reach out. Yeah, so that's it. Thank you for listening. Bye.
That was absolutely amazing.
Yeah, that was awesome, Matthias. And besides being the rock star of the Gothenburg HashiCorp user group, you also really rock this talk. I'm a fan of the way you structured your Terraform code. It is a lot of code, but structuring the way you did it makes it very understandable and easy for others to deploy. And I also loved how you used the new boundary alias target resource. What are your thoughts there, Karim?
It's, you know, we were talking behind the scenes, like this is the largest provider file I've ever seen. And that is because you're touching so many different parts, right? You're talking about GitHub, you're talking about AWS, Entra was in there, Microsoft Entra, of course, the boundary provider, HCP, everything. This is a solid solution. And I love that Matthias shared the whole repository with us actually, and we'll share it with you in the chat. So definitely check it out on GitHub. It is well worth to learn from this one. And of course, if you were paying attention, Matthias was standing right in front of a banner of the HashiCorp user group that he represents. And while I totally love the idea of going to Sweden to attend a meetup there, Not everyone has that opportunity, right? But it's not a problem. We've got HashiCorp user groups in 64 countries, a total of 180 groups, 185, I think, at this point, 52,000 members. So there's a fair chance there's a user group next or near to you. Reach out to your local user group, propose a talk, join a meetup. Get involved, have some fun. I ran the Amsterdam user group ages ago. It was probably the best way to connect with other HashiCorp interested people, talk about Terraform, talk about best practices. It is absolutely a great way to learn new skills and to network.
Awesome. And also, please, side note, remember that we'll be sharing all of these talks on YouTube in the coming weeks. So if you're just tuning in, you can catch up later. Now, our next speaker is Michael Kozer, and Michael's going to show us how to hook up your Python web applications to Vault using the Vault agent and the Vault proxy. Michael, the floor is yours.
Hello and welcome. My name is Michael Koser. I am a developer advocate here at HashiCorp, and today I will be talking about how you can decouple secrets management from your Python web applications. Now, today's talk is going to focus on virtual machine-based deployments. So if you are hoping for containerized workloads on Kubernetes, unfortunately, that's not what the talk today is about, but we do have a lot of great content, blogs, videos, tutorials out there to help you with that journey. But anyway, back to our talk. So here is a common deployment pattern that I have seen for Python web applications. Users interact with an application server, and then that application server is sending requests to a number of your Python web apps. And it's called a pre-forking model because the app server actually forks multiple processes of your application. And it manages those applications. So you can tell the application server to reload the application, and it will gracefully stop any working processes and spin up new processes in its place. And those new processes will take new configuration, they'll take new secrets, and it allows you to very cleanly and without downtime replace your application. Now, there's a number of application servers on the market today. In my demo that I'll be showing later on is using gUnicorn, but there's also Apache Mod Python or even Nginx Unit. Now, there's two key things you want to keep in mind. You want a application server that can handle hot reloading its own TLS SSL certificates. And then you also want an application server that gracefully can replace worker processes without downtime. And so those two things are critical. A lot of application servers on the market do those things, but if you're definitely going down this path, you want to make sure that you're doing those things. Because the application server is doing a lot of the heavy lifting for us, that grants us the flexibility and freedom to choose any Python framework that we want to. And so, for example, in this demo, I am using Fast API, but you could also use something like Django or Flask. Now let's talk about secrets and Python web apps. So in this example, I have a virtual machine. It has TLS SSL certificates in a file. It has secrets in a file, and the application server is pulling the certificates, and each of the worker processes is pulling the secrets as well. Now we can implement Vault Agent here. And so Vault Agent is a standalone binary that runs in its own process alongside our application. And it manages the authentication and secret generation and renewal lifecycle or process. And we're running it alongside our application because we're decoupling it from the source code. So remember that this whole purpose is to keep our source code clean, simple, and elegant. And we do that by running a separate process. So we're kind of shifting secrets management from a developer process to an operations process. So the developer process or development process stays really simple, and there's a little bit more complexity on the operations side of things because we have to run another binary. But the cool part here that I have highlighted in red is that once the credentials change, Vault Agent can issue a reload statement, such as a SIGUP, and it will send that to the application server, which then will gracefully replace all of the worker processes, which then will get the new secrets. So that's it for the diagrams. Let's jump into a hands-on demo. So this is the demo that I will be showing. It's available here on my GitHub at Vault Python Web App. Feel free to follow along, or after the talk, after HashiTalks Secure, feel free to jump in, dive in, kind of dig into the code and see how I'm doing everything, because I won't have time to cover everything today. So let's jump over to VS Code. So here on the left-hand side, we are leveraging, this is our settings.py file. So this is setting up all of our settings for our application. And we are leveraging Pydantic settings to do a lot of the heavy lifting for us. So we have a number of classes that represent the various types of settings that we may have. We have app settings, AWS settings, database settings, Vault settings, and then we have our top kind of parent settings, which then has all of the other settings nested within it. And that just gives us a nice single settings object here. But scrolling back up to the app settings at the top, we can see that by using Pydantic settings, we can define where Pydantic should look for these configuration items. So here we're setting a name, an admin email, an API key for our app settings. And that's going to be looking for app.env. So we're going to leverage Vault Agent to generate that app.env file for us. And so on the right-hand side, we can see that this is app.env, the Consul template, which Vault Agent will use. So we're pulling from kv/demo, and we're storing those secrets into our environment variables here. And then for AWS settings, we have our access key, our secret key, and session token, and that's exactly what it looks like in the Consul template. So we're pulling from AWS STS example, and then we're storing the access key, the secret key, and the session token into the corresponding variables here. And finally, our database, again, we're pulling our username, our password, host, port, and database. This one's a little unique in that half of the data is coming from the KV engine, and then the other half of the data is coming from the dynamic database secrets engine. So we can see here the KV engine, kv/demo for static, and PGSQL creds demo for our dynamic credentials. Now for the demo, I have it set to a TTL of 10 seconds, which is very quick, definitely for demo purposes. In a production environment, you may want to do 90 days or 30 days, depending on your organization's policies. But for demo purposes, I think doing 10 seconds is really nice, and we can see that here. So next we'll jump over to the Vault Agent configuration. So we can see that we're pointing it to a Vault cluster, which I'm just running locally. The next is our auto auth method or stanza here. And this is just defining how we're going to authenticate into Vault. If you're running in the cloud, you could use the cloud auth methods, AWS, GCP, or Azure. But for my demo here, I'm just using AppRoll. Next, we have our various templates. And we have a template for each of our settings. We have our app.env, vault.env, and database.env. So we're pointing a source and destination for each of them. And then we can also define things like file permissions, the user, the group, who owns the file. And then the most important part is this command. So this is what do we do once new secrets exist? And so this is just saying, is the gunicorn process active? If it is active, let's reload it. Otherwise, we're just going to say true, because otherwise we don't want to error out. So the true is just there so we don't error out. And we're going to do that for all of our templates here. And I do have the AWS one commented out because I don't want to accidentally leak any AWS credentials here. And at the very bottom, you'll see here that we have a PKI template as well. And it's doing the same thing. It's writing this to a specific cache, and we can take a look at that console template as well. So here is the console template markup language for this. So a little bit more complicated. We're pulling a PKI. We're issuing a certificate for our demo. We're telling it it's webapp.example.com. And our TTL is 24 hours. And now we're going to store, this is doing a little bit more advanced items here, but we're going to store all of these items into a cache. And then we're going to leverage these functions, the write to file function, to write specific items to other files. So we're going to write our key to server.key. We're going to write our cert to our server.pem, and we're going to append it with our CA, also to server.pem. And here we can specify, the user, the group, and then the permissions of the file. So this one's a little bit more complicated, but I thought I would just show it out here as well. So that's all of the code. Again, it's very simple. Our application, nowhere in our settings did we mention Vault. All of that is handled through an external process. Our Python web application is only calling these specific files, which very simplifies our Python web application. So now we'll jump over into terminal and we can do kind of a hands-on approach. So I'm going to run this. This is a load test against our application. So I'm going to run this test for 1 minute, and it's going to hit our application 200 requests per second. We're going to hit the DB users endpoint, and that's just going to pull users from our database, just to show you that we are in fact doing things. And then it's going to generate a nice clean report. So I'll run this, and in the meantime, we'll hop over to this other tab, and we'll talk about the settings here. So here I have highlighted the database username and password. So what this whole page here is doing is a curl command against the sysinfo endpoint. And that's going to run every 2 seconds. And remember, our database credentials only last 10 seconds. So we should see these change every 10 seconds as I'm talking, right? So Vault Agent is pulling credentials. It's keeping track of the least, the max TTL. When credentials need to be recreated, Vault Agent generates new credentials and then stores them into the file and then tells our application server that new credentials exist, please reload the application. And so as I've been talking, we can see that the username and password here have been rotating every 10 seconds. And we can also see other things as well, our application name, our application email, API key, and our Vault various configuration items here if we wanted to use transit or transform engines for advanced data protection purposes. Additionally, because I showed the PKI engine, we can check that out here as well. So I'm going to run this curl command against our web application, and we can see that our subject is the webapp.example.com, which is what we had it set to. And we can see from our start date and expire date, these are 1 day apart, which was our 24 hours apart. Additionally, we can see that the issuer is our intermediate authority for our Vault, which is our intermediate authority here as well. So this was just a very quick and basic introduction to Vault Agent, PKI, dynamic secrets, static secrets, and everything. So all of this code is available out on GitHub. We will now jump over to our load test, and we can see that we ran 12,000 total requests, which was 200 requests per second. And we can see that 100% of them were successful, with our status codes being 200 for everything. So throughout this whole process of constantly changing and regenerating our database credentials and reloading our application, although we were hitting our application 200 times a second, we were still always online and always handling requests from our user. So that is about all of the time that I have left. Again, all of this code is out there on GitHub. There's even in the code, I can show you that real quick before I run out of time. There is a demo and a README. And so this README goes through everything you need to do in order to get this up and running yourself and hit all of the various endpoints. But with that, I will end it here. Again, it's on GitHub. Feel free to reach out to me on LinkedIn. My name is Michael Koser, and it's been great. I hope you enjoy all of the other talks that we have here at HashiTalks Secure. Thank you.
Cool. I really love how easy and more scalable it is now using the Vault agent and the proxy. Seeing the secret reloading real time was really cool, Michael. Thank you very much for your talk.
That is definitely a cool demo. It's the easiest way to show how secret rotation works, right? And it's probably the easiest way to convince people that, one, it doesn't have to be hard, and two, it actually works. It makes sense. This is not some proof of concept. It works. You should do it. There's no reason not to. So, what is it? Almost 45 minutes ago, we asked the chat, tell us where you're from. We're going to pick a winner. And we had some really cool cities and locations show up. And I know, Jasmine, you really tried. I'm sorry, I should have specified this offer is not valid to people who work the stream behind the scenes. We appreciate your work. You cannot win, but that means we haven't picked a winner yet. And that means somebody else has a chance to win. So drop where you're from in the chat. Let us know so we can pick a winner. Sorry, Jasmine.
I like you, Jasmine. But our next speaker is Jorge Alcalo, who's going to show us how to set up secure and keyless access between HTTP Terraform and Google Cloud. Jorge, take it away.
Hey, good evening all. Welcome to my talk about securely accessing Google Cloud from HTTP Terraform. My name is Jorge Alcalo, and I will tell you everything about it. Let me first introduce myself. I'm the practice lead for Google Cloud Security at Xebia. Besides that, I'm also Google Cloud Security Architect, meaning that I help our customers design and build secure solutions on Google Cloud. I'm also a Google Cloud Trainer, so helping sure that we can enable our customers to do it themselves, creating secure cloud environments. And what I really love is bring people together around the Google Cloud topics in our Google Cloud user group, Benelux, that we organize at Xebia, but also together with Google and HashiCorp. So let's see what to expect today during our talk. First, I'm going to talk to you about the problems. What problem do we face when it comes to securely accessing Google Cloud and connected to HTTP Terraform? Of course, we don't want to talk only about problems, also solutions. So I'm going to tell you more about Workload Identity Federation. What is it and how can you use it? Another one is how to scale this solution that we're going to share with you tonight for the enterprise. And of course, I'm going to show you a demo. How can you use it? Terraform Cloud together with Google Cloud. So let's first start with the problem, right? Already mentioned a bit. The problem is that service account keys are not secure. So what's the problem? Well, first of all, is the thing when your service account key gets compromised, right? If a hacker gets your key, he's able to provision resources in your Google Cloud, destroy existing resources. And it's also one of the reasons where you see things like crypto mining, that kind of stuff going on in your Google Cloud environment. And one of the other things that causes a problem is that sometimes, due to security reasons, some organization already applied the organizational policy to block the usage of service account keys. So you're not able to export them and to use them. So how are you able to connect them to external platforms? So what are we actually looking for, right? We discussed what the problems are. We're actually looking for short-lived tokens with limited permissions. So actually we want to have our tokens that are unique for each Terraform run and that have a short lifespan. I think that's really important. And another one is that we want to have granular access. So applying the principle of least privilege, making sure that we are able to impersonate service account that has limited permissions. And in case that a token gets exposed, then we minimize the blast radius. So That's about the problem. Let's look a bit what solution do we have. Workload Identity Federation. That's a Google Cloud native solution that helps to federate identities on Google Cloud. Let's take a look. What is it? Well, first of all, Workload Identity is the way for keyless authentication in Google Cloud. The platform that provides an OIDC endpoint can integrate with Workload Identity Federation. And what's really nice, it is based on OAuth 2.0, meaning that Workload Identity on Google Cloud is based on the OAuth 2 token exchange, and it gives a token back to the OIDC endpoint, meaning that in this way you're able to impersonate the service account that you can run with limited permissions and provision your resources on Google Cloud. It works with different platforms that support OIDC, so of course HCP Terraform, but also Git, Kubernetes, AWS and Azure. Think about the Active Directory. So let's take more zoom it out to the high level architecture, right? Here you see the HCP Terraform on the left and the Google Cloud on the right. So what do you actually see happening? I see a few dots on the map starting with the workloads. So the first thing that we need to do in order to make this solution work is to create a workload identity pool in your Google Cloud platform. That's step one. And you also see the workloads in the Terraform side. That's actually the workloads where you have the workspaces where you actually want to run your Terraform plans. So if we look for the second part is where the app needs to authenticate with the identity provider, where it can receive the account credentials. That's the second step. So let's look at the third step, because what will happen, the app calls the security token service on the Google Cloud sites, and it will get a short-lived Google Cloud access token. Okay, nice. But what will then happen is on the side of the HCP Terraform, where the dynamic provider credential is in place, that will help you and use the token to impersonate the service account that's on the Google Cloud side. And I think that really shows the magic combined with the workspaces, what I'm going to tell you a bit more about it. So that's high-level the solution of Google Cloud Workload Identity Federation. So let's make it a bit more concrete. Like, let's look at the building block that we have in place. So if you want to get started, I have actually created a repo and also Terraform workspaces based on those two folders. So it's a repo with a setup WIF, Workload Identity Federation, and the one to actually use it and consume the service. And I'm going to walk you through the code and also show in the demo how you can use it. So let's start with a setup, right? Because before we can start using Workload Identity Federation, we need to make sure that we have already a connection between HCP Terraform and Google Cloud. We do that by leveraging in the first place a service account key. That's the thing what we need to do in order to make sure that it has established connection. So let's dive in. So one of the first steps that we need to do, as mentioned before in the high-level solution, is create a Workload Identity Federation pool. Well, you actually see it right here, right? What we actually recommend is to create non-Google Cloud environments that they get their own pool. So here we see it, right? HCP Terraform pool. You just see the ID, display name, description, and the resource is the IAM Workload Identity pool. So that's step one. So let's take it a step further, right? Because now we need to actually create the Workload Identity Federation provider. We see it right here, the resource within Terraform. And if you look on the screen, the really important stuff, what we see here, specifically looking at the attribution, the attribute conditions, and also the mapping. And I'm also going to show them to you looking on the deployed resources on Google Cloud. But what's really most important, what this is doing, it will make sure that it will map the Terraform workspace, so that's allowed and the organization to actually work together with Google Cloud and authenticate against it. So that's really attribute mapping, the most important part that's happening here in the federation provider. Other thing already mentioned, we want to make sure that not all workspaces in the connected Terraform organization are able to execute and authenticate against a Google Cloud. So I want to make sure we can control it, right? So how to verify that? That's actually where this part of the code comes into play. Here we see, for example, the workspace IDs that I have specified here. That's actually one of the use Workload Identity Federation workspace in Terraform. You'll see it also during the demo. I've defined here the ID. So that's a really important one, not the name. And if you go back all the way down, they actually see the mapping of the member. That's part of the IAM member. You can see them here. And I also match it against the Workload Identity pool and together with the workspace ID. So that's really a really important one. And actually, you might wonder, hey, the workload IDs above, that's actually part of the locals where we define the workspace IDs. So in the Git repository, you also see the code, so you can use it from there. Yeah. So, and the final part I mentioned is actually the mapping of the attributes from the workload identity federation against the workspace IDs in Terraform. So that's really important to check that out. So we discussed about that we want to impersonate a service account. Then of course the most important thing is to start creating a service account. That's actually what we do on this part of the presentation. Here you see the resource. We're going to create a service account in Google Cloud, example 1. And on the bottom you actually see that we're also granting specific permissions to this service account, the one that we will impersonate during the Terraform run or apply. So it's really important here that we don't give them too much permission. So this is about a storage admin, and luckily you see here we don't assign the owner or the editor permission. So that's really nice. We limit the permissions for the service account that will impersonate. So now we talked about setup of the workload identity federation with Terraform, the steps that I just discussed. Now we're going to look into how to use it. How can we consume workload identity federation in our Terraform workspace? Well, actually, here we have it. Let's walk it through. So here we start with the locals. Again, we define what Google Cloud Project ID, what bucket name, the prefix we want to use, because they need to be unique, of course, within Google Cloud. I have a little randomizer of the ID, just to make sure it is unique. And then, of course, the most important part, we actually creating the Google Cloud Storage bucket, the naming convention, the region, and of course, referring back to the Google Cloud Project ID where we want to create it. And actually, that's it. That's actually how we can consume and use the workload identity federations in a different workspace within Terraform. So you can imagine, is that all that we need, right? There must be some magic in the Terraform provider. Well, let's take a look, right? Because this is actually where the magic happens. Here you see actually the sequence. And let's take a better look actually at it, because what we here see, we have the Terraform agent on the right. Hope we can see it there all the way in the top. The Terraform agent calls the Google Cloud Workload Identity Federation actually to obtain the federated token. So that's actually what's happening in the first part. Then you have the federated token that's passed on to the Google Cloud Terraform provider. That's the one you see in the middle. The Google Cloud Terraform provider then impersonates a service account to obtain the temporary credential that you see there almost at the bottom left. And that's actually being used to obtain the credential when applying or planning the Terraform. So I think that's really important, and this is actually where the real magic happens. And this magic is possible because of the dynamic provider credentialed from Terraform. Coming back to the provider, that's actually where magic happens, right? So, but of course, I want to show you how does the provider config looks for the usage of the workload identity federation in this specific workspace. Well, here we see it. So, of course, we're leveraging Terraform Cloud. I here define the organization of the Terraform. The workspace, of course, that's really important because that's actually how we distinct them. We have the setup workload identity federation, and of course also the use one. And then we have the required provider. And actually that's it. So you don't see anything, no reference to some keys, because it's all keyless and it's all being done through the variables, what I will tell you a bit more about that. Moving on, if we want to look like this is a solution, right? How to set it up and how to consume it, but how can you scale this for enterprise? Because there's a great way within HTTP Terraform to scale this and delegate the access to other workspaces so that they can also consume the identity workload federation. So in order to scale this for enterprise and delegate it to other workspaces in Terraform, what we need is variable sets. We can create them in HTTP Terraform, and here you see them on the screen, right? So we're creating the variable set to make sure that we have the name there, and onto the sets we can connect the different variables. So I have the provider authenticator, that's one part. Then we're moving on because we also have the service account email. That's one of the things, and you see we mentioned it, we marked it as sensitive, that's really important here. And the other one is the provider name. We also mark this one as sensitive. So that's actually where creating the variable set. And of course the next step is actually, when we have created the variable set, is actually to share it within Terraform and to other workspaces. So what we see here, we want to share it. So for every workspace that we have, workspace ID that we have defined in Terraform, we want to make sure that they're able to exit. So here you see it, we have the workspace variable set, that's one part. and we say for each workspace ID. So in the locals, you see down below, we again defined here the workspace ID. So not the name, but the workspace ID of the Terraform workspace. So that's really important. And in this case, we're able to share it only to the ones that are defined here. Okay, so to wrap it up, let's go to a demo where I'll show you HashiCorp Terraform and also Google Cloud Consul, the resource that we deployed with the code that I showed you. Here we have the code here. This is the one to actually set up the workload identity federation. Okay, so now we're at the demo part. We're going to walk you through the code and in the end also show the results in HTTP Terraform and also in Google Cloud. So here we see in the code the local variables is actually for the setup of the workload identity federation Terraform plan. Here you see the organization that I have assigned to it because that's actually where the project lives. Here we have the workspace IDs. Actually, these are the workspace IDs. Those are the one in Terraform that are able to use our variable set. We'll cover that in a second. Of course, we first need to create the workload identity federation pool, as mentioned before. So here we have the pool, and then actually the magic happening here at the pool provider that we create in HTTP Terraform. And I think that it's really important to mention the mapping of the attributes, right? So we have the one on the Google side, and we want to make sure that we map them for the full workspace, the workspace IDs of Terraform, so they are the one that are able to access and consume the workload identity federation. And of course, we also have the easier URI. That's the one, the app.terraform.io, really important one to mention that one. And then, of course, now we have the pool and the provider. Of course, what we want to do, we want to make sure that HTTP Terraform is able to impersonate the service account. But then, of course, we need to start with creating the service account. So here we see the service account that we create here. Moving on, we want to make sure that we grant the service account the correct permissions. So for this demo, what I'm going to do, I'm going to assign them the storage admin because I want to make sure that we can create a cloud storage bucket. And we want to delegate this access to another workspace. So that's something that I'm going to show you in a second. So that's what's happening here, right? The granting the permissions. So we don't use owner, no editor permissions, something like that. So really the right amount of privileges for our task that we want to do. So, and here what we do here, in the IAM member, we want to make sure that only the workspace IDs that we have are the ones that are allowed to impersonate the account. So here actually have it. You see the identity pool. So we want to make sure to check, hey, is it the same identity pool? And of course also the workspace IDs. So only those are the ones that are able to impersonate the service account within Google Cloud and provision the resources. So we covered the granting the permissions. And then the other part that we need to do is create a variable set. Why do we need to create a variable set? As mentioned before, if you have multiple workspace or multiple teams, if you're 1, 2 engineers, or even 1,000, what's really important that you're able to delegate access in a scalable way. And workspaces are able to help you combined with the variable set. So here we create the variable set. So we give it your name. And good to know is that we already define organization. Why is that? Because the variable set lives within HTTP Terraform on the organizational level, and from there you can delegate the access to other workspaces. So here, of course, we define what type of variables do we want to provision. First of all is the provider authenticate. Then we have the account email for the GCP run service account. And we also have the provider name. Really good to mention is that the account email and also the provider name, those are actually mentioned as sensitive, marked as sensitive to make sure that we keep it safe. So, and then of course, what we need to do, we need to make sure to bind it, right? To make sure that the workspace that we have, so we have 2 workspaces to begin with, and also in this demo, one is to set up workload identity federation and the other one is to use it. And here we're going to share the variable set that we created on org level, and to make sure it's able to be consumed by the workspace IDs for each of them that we defined in the locals. And short heads up, let me go up. Whoop, here we have it again. So that's actually the part that we covered, the first part, to set up workload identity federation. So we've just showed you how to set up Workload Identity Federation, and now we're going to move on how to consume Workload Identity Federation in your other workspace. And you might wonder, Jorge, why do you have at least two workspaces? One to set it up, and the other one to use it. Well, the reason is that you can actually separate the managing of the authentication part, for example, to your security or platform team, and the engineers you can assign to specific workspaces, and they don't have to worry about authentication, right? So they can work autonomous, just doing their things that they want to do in a secure way, and you can keep that authentication part towards Google Cloud centrally in your other workspace. So looking at the consuming part, right, where we can use Workload Identity Federation, you have the local variables, right? We refer to the Google Cloud project and the bucket name, because as mentioned before, we actually want to create a cloud storage bucket. Want to make sure that it says a randomized name, right, because it should be unique. And actually here we have the creation of the cloud storage bucket. And you might wonder, what is this everything? Well, actually, this is it, right? If I go to the provider of the use Workload Identity Federation, you see, of course, we have the organization part and the workspace. But actually, that's it. That's actually referring to the magic that we talked about, right? So this is actually part of the demo in the Visual Studio Code. Let's move on to HashiCorp, to HTTP Terraform. So what we see here, if you never used it before, here we see the workspaces, right? So we have two different workspaces. One where you can set it up and manage all the authentication, right? The Workload Identity Federation. And you also see the second workspace, the use Workload Identity Federation. You can give it to your team, right? Delegate the access. And I'm also going to show you the part of the shared variable sets. So here we have the run, and of course they were successfully finished. So we're also going to show you in Google Cloud how the resources are actually there. So this is the overview, right, of the workspaces. So what I'm first going to show you, here we have the variable set. That's pretty cool, because one of the things that I show you in the code is that we actually delegated to specific workspaces. We use, of course, the workspace IDs in Terraform, and here you see the functional name of it. And you see it's only applied to that workspace or project. Here we have the variables. So the thing is, I mentioned some of the variables need to be mentioned as sensitive, right, to mark. So for example, if we want to click on this one, edit the variable, you don't see anything, right? But that's, of course, only one part of the puzzle. Because if I go to the other workspace, this is the use one. So this is actually where we want to consume a Workload Identity Federation as a separate team, right? In your engineering team, you want to make sure you're just able to deploy with Terraform. And I go here to the variables. And actually here you see them. And those are actually inherited from the org level. Here you see variable sets. And of course, that was only possible because I mentioned the ID and the mapping. So this workspace is able to use it. And also here you see these variables are marked as sensitive, and I'm not able to see them. Yeah. So it's actually part in the workspace. And here you see just the plans, Terraform plans that are there, and they are run. So that's one part. So let's move on to Google Cloud Console to see actually what happened there. So here we have it. Here we're in the Google Cloud Console, and I went to IAM because Workload Identity Federation is part of identity access management, right? It's all the identities and making sure they can authenticate. So here you have it. Here you have the pool that has been created. And of course also the provider. If I click on edit, you might see some familiar settings. For example, the issuer URL. We see it here referring to Terraform, HTTP Terraform. Oh, it's of course enabled. Here you see the attribute that I showed you in code. Here we see them. And of course, here you'll see the mapping towards the Terraform organization. So that's one of them. If you go back. So here we also have the connected service accounts. And that's actually the service account that we have created and the one that we want to impersonate. You also see that this service account, as mentioned, is only allowed by the workspace ID that we mentioned. And actually, you can see it right here. This is actually workspace ID from Terraform that's allowed to impersonate this service account. So let's take a look actually if it actually was provisioned, right? So we talked about creating a cloud storage bucket. Here we go. There it is. HashiTalks folder it is with a unique identifier. So this is a storage bucket. And if I go to permissions, whoop, you actually see the service account for HTTP Terraform. And it has the proper permissions, the storage admin as we assigned and declared in the code. So that's just a part in the Google Cloud Console. So what I've showed you, I showed you in the demo from looking at the code in Visual Studio, then going to HTTP Terraform, seeing in the console how is everything being configured, how we share the variable sets to a different workspace, and also how everything has been deployed in Google Cloud. Now we're almost ready at the end of the talk, and let's take that back. What have we discussed? So the first thing that we covered were the security risks of using service account keys, right? That was the first part. But also we talked how can you use workload identity federation to actually authenticate without keys. Third part we covered is how can you scale this, right? I mentioned scaling for the enterprise, but actually it's also if you're with 1 or 2 developers, you're able to set it up in a great way where you separate the setup of the workload identity federation and also the usage. So the developers can do the great things and don't have to worry about authentication. And finally, you've seen this all in action. I hope you enjoyed the talk. My name is Jorge Liao, and let's connect. You have the QR code and the link to my LinkedIn profile, but also to the GitHub repository, where you can find all the sample code showed during the talk. And thank you very much.
Awesome. That was a great talk, Jorge. If it taught me anything, is that everyone should move to workload identity. Really well explained, and I loved your talk. Also, it's nice to see that you've open sourced the code. We'll make sure to share the link. Thank you very much, Jorge. What are your thoughts, Karim?
I think it is what you say, right? Like we should always strive to step away from anything that's hard-coded and long-living tokens. And that is a great mission statement for any operations and SRE team. But it's a really hard mission statement to fulfill. And I love the quality of the talks we've had today, Jorge, and of course, Michael's demo, and also what Matthias showed us with code ready to go, stuff that you can test out on your next easy day, hopefully Friday, because tomorrow you're still going to be busy watching HashiTalks Secure and just trying to see how you can implement it for your team and your platform.
Awesome. All right. So our next speakers are Roddy and Sunil, who will talk about how they've extended their secret manager vault from serving microservices to their data pipelines. Chat, please welcome Roddy and Sunil with their talk, Vault, Secret Manager for Databricks Pipelines.
Hello everyone. Today, Rati and I will be talking about how the Vault, being a secret manager for the Databricks pipelines, helped us to enhance the data security and compliance, overall to achieve data governance part of it. First of all, huge thanks to HashiCorp Vault, who gave MIQ an opportunity to talk about some of the great work that we do with respect to secret management. Brief introduction about both of us. I am Sunil Khandelwal, currently working as an engineering manager in the processing team, a team who enables MIQ to analyze an action on top of any data in the secured and the governed manner through some services, technologies, as well as platform like Databricks. I have Rati along with me, who is a tech lead in the processing team. And this is like what we are going to talk about today. We'll talk about what MIQ is, what we do as a business. We'll spend a couple of minutes on the problem statements that we are trying to solve and the approaches that we took, followed by the solutions that we designed, the secret interfaces that we built, as well as Q&A. Brief introduction about MIQ. We are MIQ. We are like leading programmatic media partner. We have been in this industry for the last 12 years, and we have partnered with multiple agencies and the marketers to deliver programmatic media buying through connected insights and data-driven technologies. We have served 100 billion plus impressions as of day to day. We have worked with 10,000 plus advertisers across globe. We are 1,100 plus employees who are spread across 9 different countries. We have won so many awards, not only for the services or the solutions that we build, but also for the people and the culture that we have in MIQ. We are like a 1,000+ strong team of award-winning programmatic professionals, which includes top client services professionals, commercially minded data scientists, expert programmatic traders, who helps us to build the strategies to run the media campaign. We are a people-powered company. When we say we are people-powered company, we are not saying it. We do hire inclusive and diverse people in the team, and this is the only way to help our clients to outperform their competitors. We have won 10+ awards in 2023 for our people and the culture. Some of them like Best Places to Work 2023, Best Firm for Data Scientists to Work with, so on and so forth. This is the glimpse of how the programmatic media advertising happens. You can say a small component of EdTech. Imagine like a user visits a web page and there are lots of ad slots are coming up, right? What happens behind the scene? Website publishers communicate with ad marketplace to put up impression for an auction. While there are limited number of ad slots are available and million of people are trying to put their ad and impressions in the given slots, which demands a real-time auction. And the real-time auction is held among the advertisers competing for that particular impression. And that's where like MIQ team comes into picture, being an MIQ being a programmatic media agency, work with the advertisers and ensure to provide a medium to do real-time analytics, data science, and modeling, and ensure the right user is being targeted for the right personas. And the beauty of this is it happens within a 0.1 or milliseconds of time period. And the advertiser with the highest bid wins. And this is being held for the several years. And MIQ is trading like 40+ billion impressions on a daily basis, generating 20+ terabyte of data on a daily basis, and which helps us to compute who is the right advertisers we go ahead with and whether the advertiser is meeting the intent of targeting the right users in its own context or not. Moving on, like as we know, the data plays a very important role in any of the decision making. That's how like data is at the core of programmatic decision making as well. And some of the stats that we have collected, where like MIQ is running like 2,000+ campaigns on a daily basis, generating and processing 30+ terabyte of data. We are running 3,000+ database job, for which like incurred cost is more than $40K monthly DPU. We have like 7,000+ trading strategies, and 750 million users have been targeted so far. Let's come to the problem statement. So to serve the programmatic media decisioning, right, we generate terabytes of data, process terabytes of data, which requires data ingestions, pipelines, and the processing jobs. And hard coding the secrets directly into the data pipeline is a common but a risky practice, which possesses several security and the operational challenges, and which requires a secret managers to be used. And that's how like we divided our problem, or we looked up the problem statement in 4 glances. How can we capture the hard-coded secrets which are already exist in the data pipelines? How should we fix how do we build an automated system to move the hard-coded secrets to a secret manager? And how do we ensure that no more secrets are added in the future created pipelines, as well as without disrupting the user experience? With that, I will hand over to Rati, who will talk about like the approaches that we took, the solutions that we designed to solve this particular problem. Over to you, Rati.
Hello, everyone. Thank you once again for joining us today for our talk. I'll take over from where Sunil left. We'll go through quickly towards that approach that we have taken to solve this problem, and then we'll deep dive into each one of them one by one. Starting off with the very first problem, that was capturing the statistics. As Sunil mentioned, that we had secrets flying around across all our repositories, and we were coming across it, but we did not have any consolidated report on how many secrets are we talking about, what kind of secrets are we talking about, where is it lying, who owns it. So our first step was to capture all these statistics. For this, the tool that we used was Trufflehog, quite well known. And eventually, we also added Git leaks into our system. We captured all the results, stored it, and we had that repository ready with us, telling us how many secrets, where it is lying, who is the owner of it. The next step for us was fixing it. Now, fixing this problem had 2 parts to it. One part was one-time replacement of all these secrets lying across. And the second part was providing users a utility through which they can talk to this new secret manager. So what we did as part of the first fix is we created user-level folder structure in Vault. Every single user within a MyQ got their own folder so that they can store their secrets over there. The second one was automated secret push and replacement of that. So we had to run a automated secret scan and secret push script, which captured all the secrets lying across all the repositories. It pushed all the secrets into the user's respective folder, and then also replaced the references in their respective code with the references of Vault. We also provided users with the utility library. We'll talk about the utility library in detail in subsequent slides. The next step for us was UX, user experience. This would have been quite disruptive if we had just asked user to move all their secrets to the new secret manager. And going forward also, asking them to change the way they have been doing their development by going to a new application, a new UI, making changes in their code. So what we tried to do that is we created a UI in our in-house application called Studio. Let me quickly introduce Studio to you. It's a no-code, low-code, drag-and-drop automated tool built on top of data platforms like Databricks, StreamSets, NiFi, and other data platforms. We saw an opportunity here, so we added a tool, a UI on top of this automation tool, where you don't need to go to Vault, you don't need to go to another application. In the same application, you can replace your code, and from the UI itself, you can push the code and mark it reference in your code. So we were able to capture, fix, and also improve UX for the user. The fourth step for us was to ensure that we do not end up reaching into the state we were in. What we did for that is we started monitoring on a regular basis to figure out how many secrets are stored, where are they stored, who is the accountable user for it. So we had reports scheduled, and this gets shared regularly at this point, weekly, to the respective users and the leads. Let's jump to each one of them one by one. Now, capturing of secret across the code repositories. What we did is, first of all, we figured out all the commonly used secrets in a MyQ, figured out the regex, which will be able to help us capture those, fed these into TruffleHog, and we ran the scan. The screenshot which you see on the right-hand side is the very first report which was generated, which was shared with our execs as well. And once. The second part was Python utility library, which we created. The components of that Python utility library was a library installed in Databricks. That was one component to it. Another was something stored on AWS Secret Manager, the private key, and the third component was Vault itself. So what we did is we wrote this library, and what this library does is it connects with Vault, figure out who the user is, gets a user-specific JOT token, and then makes a subsequent call to fetch the user-specific secrets. The sequence would look somewhat like this, that I go to Databricks Notebook and try to fetch my tokens. I invoke the method. What this Python utility library will do is it will make a call to AWS Secret Manager, get the private key. This private key is the one which is used to sign all the communication which is happening between Databricks infrastructure and Vault. Once the library has the private key with it, it'll make a call to Vault and get the user-specific JOT token. The call which we make also has information about user, which we get from Databricks utilities itself. And once we have the user-specific JOT token, we make another call to the user-specific path, secret engine, and folder within that, and fetch the secret which they had requested for. The third part to it was fixing the UX. So the utility library was self-sufficient, but again, you have to write code to access it. What if, as a user, I do not want to write code? What do I do? The in-house tool which we talked about, that was Studio, we actually integrated Vault with it. We interfaced Vault with Studio. The screenshot which you're seeing in the bottom left corner is the screenshot. It's partially the canvas of Studio and the feature that we have built. You can trigger scanning of notebooks from Studio UI itself, and you'll get the details about it. The screenshot which you see on top right is how you see the details associated to your task. what kind of validation, what kind of violation type it is, what match screen we are talking about. Another screenshot from Studio itself. Studio also provides you a way where you can write Python code. We integrated IDE-like feature on the Python code itself. So while you're typing your code at that time itself, in line, you'll get to know what all secrets you have added. And the validation layer will not allow you to save this unless we have moved this secret out of this code editor. So what do I do as a user if I have to remove this to a code editor? Do I have to go to Vault UI and paste it and come in a reference Vault from here? Not. You don't have to do that. All you have to do is scroll down a bit, and then you see this section of update variable where you can just paste a secret, give a name to it, and then replace the secret here in the code editor with the name that you have provided. And everything works like a charm. The fourth and the last section was monitoring bit. So we were able to capture, we were able to fix, we provided users with all the utility, but again, that doesn't ensure that nobody's going to not add any secrets in their notebook. So we have this report which is scheduled at a weekly basis, which scans all the notebooks across MIQ and generates a report and share it with the respective owner, along with that certain leads of that particular team the owner belongs to. It also gets shared with us, so we're able to keep an eye to it. The screenshot which you're looking at right now is taken from last week. It is for one of the Databricks workspaces we have called BA Commons. We have about 10, 12 Databricks workspaces. BA is Business Analytics. Commons is a common workspace which you use for different verticals. You can see that there are 10 secrets even right now lying around. The screenshot which you see on top right is of the Excel sheet which gets attached as part of the report, where you can get to know what path it is, who the user might be, and what is the detection region, and what string it might have matched. That would be it from our side. If you have any question, feel free to ask. Thank you.
That was awesome. I really love the creativity and appreciate such in-house built solutions. Thanks, Roddy and Sunil. Please all remember that we'll be sharing all these clips on YouTube in the coming weeks. So if you're just tuning in, you can always catch up later. Now, static code analysis makes reviewing Terraform configurations a lot easier. Please join me in welcoming Kasayo, who's going to talk about compliance as code using checkoff.
Thank you. Thank you, Bruno and Kareem. Hi, everybody, and welcome. I'm pleased to be here with you at HashiTalks Secure 2024. My name is Casella. I wear my Hashi socks today, but y'all can see it because I'm not that fit, to be honest. Today's topic is compliance as code in Terraform with checkoff by former Bridge Queue, now Prisma Cloud. And I will try to give you some context before diving into checkoff. But first, quick intro, if I may. So next one. Right, so my name is Casella, aka Cloud Dude. I'm a solutions architect at Eclipsys here in Toronto, Canada. I have a little more than a decade experience in IT and Oracle technology. Been a DBA for a long time until I got bored and I transitioned into multi-cloud ops and ISC the last 5 years, because that's where the cool kids are. There's not much more to say that I'm a huge cloud and automation fan, and I share all my labs and discoveries on my blog, brokedba.com, and on my GitHub repos. That's github.com/brokedba. And I also host a podcast called Tech Beats Unplugged, which I'm very excited about since August. So please check it out. You can find a cool episode where I hosted Kelsey Hightower, chilling about DevOps for about 2 hours. So that's a QR code if you're ever interested. Right, now that we're done with the intro, let's talk about the reason why we're all here today. Okay, so what are we talking about today? Well, first, we'll talk a bit about the context and compare some misconceptions and challenges that come with compliance before and after the DevOps era, the old school versus new school. Then we'll review the state of ISC source misconfiguration through a study report. And then in section 2, we'll have a similar more or less a small introduction, I would say, on available compliance as code solution, whether it's standalone, SaaS, third party, or open source based, because I did some research. Then we'll go through some concepts of checkoff, where we review the features, benefits, such as seamless integration with CI/CD, before exploring its capabilities with a demo in Terraform. In section 3, I will describe checkoff integration in a pipeline workflow in general and the best strategies to leverage it, which will be followed by just how to show a pretty HTML report of the scan results in GitHub Actions and Azure DevOps. After that, we'll see a demo with a full GitHub Action workflow, including a directory scan and HTML report, and also talk about the branch protection and how can you do branch merging protection using checkoff within GitHub Actions. And finally, Q&A, if we have time, of course. All right, so now let's start with the meme. Obviously, of course, your bosses have many expectations when they hear you're a cloud engineer, right? But this is literally my face when my boss asked me to convert more than 300 security controls from Canadian security compliance into cloud policies in Oracle Cloud Landing Zone. Why? Because it's huge. It's just a tons of guardrails to review, which is a lot to handle for a single ops person. If we want to do that from scratch, it's just crazy. Bottom line, it didn't happen because it's impossible for a single person, as I said. But we finally decided to wait for new release from Oracle of the landing zone version. This is expectable because we're actually already busy and we can't waste time in reinventing the wheel every day from scratch. It takes a service provider or even a vendor, especially if you want to be multi-cloud. But if it's not you, then who then? Usually it's the security folks, right? So let's talk about the security folks, right? So if we're talking about the security folks, usually the security departments used to be called the Department of No. No, you can't do that. No, you won't have that, and so on. That was the good old days, actually, or maybe the bad days, who knows? The on-prem days, I would say, when they had full control of the racks. But today, things are different. With public cloud infrastructure and APIs, the laws are off, and nobody begging for resources behind a JIRA ticket today, right? So all days are gone. No, it's open bar, actually, and with DevOps and new software supply chain, devs deploy with a huge velocity and way faster. But we still need to secure our infrastructure because the problem isn't gone, right? So now, depending on the organization, we see two types of trends, actually. So the first one is when security team is playing catch up with whatever the devs already pushed into production, which is kind of reckless because it's already too late. It's in production, so it's kind of too late. The second one is when companies enforce strict procedure where even with the beautifully automated pipelines, there's a review step by security team for approval that will block or jam this agility because they need to sign off. That's also bad. Why? Because these people can't remember thousands of policies and configurations to control for each cloud provider. Nobody can, actually, by heart. This is why instead of mainly focusing on security tools to security people, spoiler alert, a new type of solutions emerged to provide a whole new perspective where we give more ownership to developers. That's what we call shift and left, especially when we know that 95% of the cloud security issues are related to misconfigurations, not CVEs, right? Misconfigurations. You can take last fast breach, by the way. It's not due to CVEs. But there's more, as I want to actually show you the numbers, just not talk about it. And I want to focus more about the source, right? So let's talk about the source. Where do you get your Terraform configs? It could be a friend. It could be Stack Overflow. That's another friend. It could be Terraform registries. It could be modules, even ChatGPT. This is because everything has become declarative with DevOps and Terraform, and we definitely use external module templates every day, whether it's coming from CSP, a vendor, or any open source developer. So let's check how these Terraform templates are. Well, according to Unit 42, researchers from Palo Alto Networks who use Checkoff to analyze almost 5,000 modules templates from registries and popular GitHub repos with more than 38,000 Terraform files from GCP, Azure, and AWS. Well, they found out that overall, 63% of the Terraform templates contain one or more insecure configuration. One or more insecure, we don't know if it's serious. But on the other side, they also found that 49%, that's almost half, of the templates contain at least one critical or highly insecure configuration. That's serious, because that's nearly 1 out of 2 modules with the Terraform registry that is misconfigured. And these misconfigured modules have been downloaded over 20 million times. And these numbers are from 2021. So you can do the math for 2024, right? And when we hear about 20 million times downloaded, that doesn't mean execution or deployment, because this is actually what they're made for. Modules are made to be reused, continuously, like 100 times, right? So imagine if you have 20 million downloads times 10 times 100, we get to a billion, 2 billions actually. That's scary, right? And the most common misconfigurations are in general security, login, encryption categories. So those are the usual suspect. But what you need to remember is Terraform is not the only code that is impacted by this flag. All the declarative artifacts are also misconfigured, like Helm charts, for example, which is the most popular tool for deploying Kubernetes applications. Well, actually, Unit 42 also scanned 2,300 Helm charts out of 618 repositories. And what they found out is that 71% of those 618 scan repos contain misconfigurations. And 46% of those cards and their dependencies contain misconfigurations. This just goes to show that the default templates you find online are not secured and can be used. They're not secured by default. They can be used as is, I would say. Same thing with images. They did another research, that same thing with images. So now we realize that the more dependencies, the greater number of security flaws you end up with, right? Misconfigurations. But what can we do? Like, what can we do about it? So we know that we're overly exposed online. Wherever we touch is actually can burn you or kill you. But what can we do about it? Well, unfortunately for us, a lot of open source projects and third parties started to address this challenge. So I did some research, and let me show you the available compliance as code solutions in the market, and they're typed because there are many. Right. First, we got OPA, which is a policy-based control framework for cloud-native environments. You'll use a language that's called Rego to build your own policies, which I'm not super fan of, to be honest. And they have few projects that are dedicated to Terraform, such as Styra, which is behind OPA. They have a solution called DAS, Declarative Authorization Service, which is a SaaS solution supporting validation of Terraform code and plans via pre-built system type. Then you got Scalar, Spacelift, Terraform Cloud, like Sentinel, and all these are non-open source, but they are SaaS solutions, right? And the thing about Rego is that it's like miles away, though, from SDL or HTL. It's not super readable. And sometimes when you have to, for example, take care of those 300 control from CIS across all the cloud providers, you may not want to do them like yourself. Maybe you need the pre-built policies, although these SaaS solutions have their own built-in policies, but you may need them to be ready now, not in a few months or like from scratch. This is why we see a different type of static analysis scanners for IAC from Terraform ecosystem, like TerraScan, both TFSec and Trivy. TFSec is maybe discontinued, so I guess Trivy is like the main, the core maintained product from Aqua Security. They both from Aqua Security, and then you got Terraform compliance. So I tested them all. And you got pros and cons out there. And finally, we have the main scanner of the day, which is Chekhov by BridgeQ, former BridgeQ bought by Prisma Cloud of Palo Alto Networks, right? So before comparing those solutions eventually, let me just start to talk about Chekhov, or why Chekhov. Well, Chekhov is a static analysis tool that helps detect security vulnerabilities and compliance issues in ISC files like Terraform, CloudFormation, Bicep, and much more. It's actually the only one that supports all cloud providers, meaning even Ali Cloud and Oracle Cloud. This is something that no other tool is actually supporting so far, right? It's written in Python and scans the config file, and it's by far the most comprehensive open source ISC scanner available because it has more than 3,700 built-in policies and 2,000 only for Terraform. That tells you how much it's really comprehensive. It supports secrets and credential detections, supports extension with Git platform, Bitbucket, Terraform Cloud, etc. It has also a VS Code plugin. It has been downloaded for over 38 million times so far. It supports Kubernetes, Helm charts, Docker, Kustomize, GitLab, GitHub, and Ansible. This is actually the breadth of the framework that it supports already. And I wanted to talk also about something called dependency aware. That feature is also nice because thanks to the in-memory based mapping that can detect misconfiguration out of complex dependency, like when an instance, for example, is exposed, right, when it shouldn't. Here in this example, you can have like different components in your configuration. For example, a VPC would have an internet gateway that is attached to a route table, and this route table is actually attached to another subnet. That subnet actually is feeding the ENI that is attached to an instance, and this is how actually the checkoff is going through that mapping in order to detect misconfiguration and keep you from deploying components that are uncompliant. Right. In terms of extensions, so as I said, it supports Kubernetes manifest, YAML files, JSON files, Docker files, container files. It does that for Terraform files as well, TF-JSON, TF-vars, Terraform plans, and snapshots. Does the same for CloudFormation, same with ARM templates, and also Helm charts. Going back to the benefits, it's multi-framework, as I said, multi-cloud support, and provide also ingestible scan data with GUnit, XML, and Serif. I will talk about it later, but this is a way of seeing the results in a graphical manner, which is super cool. The second one is, of course, they support NIST, CIS, HIPAA, you name it, the whole shebang. And it's seamlessly integrated with CI/CD pipelines, Jenkins, Bitbucket, GitHub Actions. Why? Because it's a CLI. So between a CLI can run in any pipeline workflow. So that's why it's compatible with any type of CI platform, right? Because you can just install it through pipe, through pip, and then you can just run your checks within your pipeline. That's the cool part. VS Code plugin and also pre-commit. Pre-commit is good because if you want to do your checks before even committing the first time, pre-commit is your thing, is your stuff for continuous compliance. What it has also is the integration even with ChatGPT. So if you want to enhance your checkoff finding, you can just put the API key and you could run from there, from checkoff. And also I want to remind like the people that write Terraform every day that it has deep analysis and resolution. So it reads the logic of your Terraform code, like the for each loops and dynamic blocks. So it doesn't just read the static blocks, but it goes further into reading the logic and the for each dynamic blocks instead of like the static content. All right, in terms of installation, pretty straightforward. Pip install checkoff. In Mac, it's brew install, or you can even use a Docker. They have an image, so you can pull it and run it, and then mount that folder and scan it. It's pretty straightforward. Okay, next, the coolest feature for me is by far the integrated IDE plugin. They have one for VS Code, they have one for IntelliJ as well, and this would allow you to scan for misconfiguration in your AIC files from the first lines you're actually writing in your IDE, right? Against vulnerabilities and everything, right? And here you can see that it has contextual display. Once you install the extension, it starts to scan your open folders in your workspace, right? So while you're writing, it scans in the same time. And anytime it sees a block that is miscompliant, and it would just show you, for example, display the checks and highlights the link in order to see this description. That's the first part. It tells you what's wrong. And after that, that's the coolest part. It tells you the fix. So it shows you, for example, okay, you got ensure SV bucket has access login enabled. What it does is that if you click on that suggestion, it would just apply that for you. So wherever flag you need to flip, wherever feature you need to enable, it would do that for you. You don't even have to write it yourself. That's the cool part, right? And it also has one way of skipping. So if you want to skip the check, you can just add a line with a comment telling you, okay, why do you want to skip it? This is minor. I don't need it. So this is the cool part of the VS Code plugin. The only bummer here is that you would need the API key in order to have that kind of perks, right? But if you guys are interested, you can reach out to me, hit me up. I can actually maybe hook you up with something else that doesn't use the API key, doesn't have the fixed part, but at least shows you the errors. So reach out to me if you're interested. Okay, now for the commands. First time I saw the command list display last year in a workshop, it was really intimidating and confusing because it's like a bunch of lines, and it was hard for me to wrap my head around it, right? This is why I will not do that today for you guys, and rather just explain the few useful commands and flags that I use, and so we can focus on just what matters, if that's okay with you, right? So the first one is directory. So it's pretty straightforward. You have to specify the directory. And then you have the -F in order to be specific. Sometimes you only want to check one file. There's only one main file, for example, and then others you don't want to check them. You can do that. And one thing you need to know, I told you I tried all the tools, right? So for example, some other tools like TFSec, they don't have the file argument. So it's either the whole directory or nothing, right? Some other tools like Trivi, for example, they're not recursive. You have to specify that it's recursive. Otherwise, you will not check the subdirectories, for example. And Trivi has only 1,430 policy-ish versus Chekhov that has 3,700 already. So that tells you actually the difference, why it's the go-to tool. In Terraform compliance, for example, it cannot scan files without a TF plan file. So if you don't have a plan file, forget about it. It's not going to run, right? What else? We have framework. What I like about framework is sometimes you're in a monorepo. You may have like, I won't say messy, but yes, let's say it. Sometimes you have many frameworks, many files. You have Kubernetes manifest, you have Docker files, you have charts, and you don't want to scan them. You just want to scan the Terraform part, but it's within the same repo. I'm talking in case you have a repo in GitHub, right? You have some workflows, right? And you don't want your checks to actually take 80% of your build time, because people are going to get mad at you if you actually spend the whole time in scanning instead of deploying, right? So this is why you can use, for example, framework when you do your checkoff scan and specify Terraform, even though you have 1,000 files that have nothing to do with Terraform within your monorepo. Remember, it will scan everything, right? So it's recursive. So watch out. Sometimes it's better to specify the framework too. The other one is, this is one of my favorite because it's really useful. So the quiet will just display the failed checks. It has many checks that will pass, but between you and me, who cares about what passed? It's good to know that it's safe, but in the meantime, like you don't want it to be shown if it's thousands of them that are passed, right? So you just show the ones that are failing, which is good. The second one that I like, I usually use them in pair. Those are my favorite pair, is the compact. So why do we need a compact? The compact actually is not going to display the snippet of your resource that has a problem, right? Why do you need this flag? Because sometimes you actually have like a big configuration. You don't have for each. You don't have dynamic blocks. So you have 20 of the same type of resource, right? And they all have the same type of error in your check, right? Would you have it running with the same error with the snippets? Do you want to see the same snippet of every of these resources? Or maybe focus on the type of the check, right? So if you have 20, you have the type of the check that is failing, right? It shows you which resource in the line in the file, but it just doesn't show you like the additional verbosity. So this is why I like quiet, that doesn't show the past one, and compact, that doesn't show you the snippets. What else? You got the check. Check again, for example, you just want to check the encryption-based checks from Chekhov on an AWS configuration, right? You specify those checks, right? And you want check for anything else. They have something related to severity as well. You can specify, for example, medium severity. If you say check medium severity, what does that mean? That means that anything beyond medium is going to be scanned. Anything under medium is not, right? The only bummer here again is that it's like a Prisma feature. It's not the community version feature, so you need an API key, right? What else? We have Softwell. Pretty self-explanatory. You need most of the time in a pipeline. Sometimes you want to check it's the first time, or it's a really, really like early stage development environment. So you want to see the checks, but you don't want to fail your pipeline, right? So because by default it's a non-zero exit code, so you want to change it to 0. That way your pipeline will finish complete without any failure, but you will still have access to those checks. This is why people use it. Then you have skip checks, same thing than the check. It applies to checks and severity as well. You can say like check for anything but this one. And then you got list. List is more if you're curious about the checks or you want to explore actually the description, etc. The best way to use it is to use list combined with the framework, because otherwise you will have 3,700 checks that will be displayed. So what you can do is, for example, list framework XYZ, and then you'd have like maybe a chunk, just a small chunk of them, and you can see the links for the description and also the type of error it is, the type of check it is. Right, that's the last one. And two other features I want to talk about, because I get that question a lot because I presented already about checkoff. What happens if you want to skip existing misconfigurations because they're okay, they're not really critical, but there's so many they can't fit in a one-liner checkoff command with a skip check, right? Yeah, maybe 100 of them. So that's crazy. You cannot write it in one line. Well, checkoff has something called baseline to skip existing misconfigurations in future scan. So once you made sure you fixed all the most critical checks on our directory, on your directory, for example, right? Once you made sure of that. So anything that's remaining is minor, right? But you have a bunch of them. What you do is you create a baseline. How do you create it? You just run checkoff D, directory path, and the create baseline flag, which will store all remaining failing checks. It's like a snapshot. And next time, even though you keep adding new resources in a future run, you will add the baseline. So you'd run that command, you add the baseline flag, and you specify the file that is created that is a snapshot, right? And what it tells the checkoff basically, or literally, is that, you know what, wherever was scanned before and was failed before, based on that baseline, don't bother me with it. Just tell me the new errors or new failing checks, right? That's all I want to know. That snapshot, anything that belongs to it, don't show it to me, which is very practical for some people, especially the more and more we have more checks that are defined, that are built in. The other one is custom policies. And what I love about it is that it also supports YAML. It supports Python because it's built in Python, but also YAML, which you agree with me is way more readable than Rigo, right? I guess I'm not the only one here. So you can see the metadata here with attribute condition, including many operators like exist, and, or logic, regex, wildcard, JSON path expression. And basically here, what it says is that it just ensures that all modules that are used within the configurations are the official AWS modules, which are Terraform AWS modules. Anything else will actually trigger a failure. And the good thing about this is that you can contribute back to the community, to the project, to the open source project by publishing this new custom policies. That's the cool part. Right, so I know this is the demo, but since we're talking about GitHub, I wanted to add this. I want to just talk a little bit about shift left approach in what it really means with checkoff, right? Just before we get to the demo. So in this basic diagram, we can see that checkoff integration is leveraged before triggering the deployment in your pipeline. So you're safe, you're secured, right? But it's maybe too generic. So however, if we go deeper in your workflow, we can better spot the stages where checkoff can even help you big time, right? Namely, number one is the ID. ID, remember, with the plugin, it's the first stage where you put your first line, right? Or you get it from Stack Overflow, for example. So imagine if you can actually avoid anything that is misconfigured, non-compliant, to be pushed in your repo from the first line you're writing. So that's the earliest stage, like most efficient one. Then we have the pre-commit. I told you about pre-commit. I like the local pre-commit. because the action one is more like post commit. But if you have pre-commit with checkoff configured as a hook, then after that you will just prevent, for example, your configuration to be sent with your credentials. For example, imagine if you push a secret in your repo on GitHub, you're done. Like the repo has to be rebased. Why? Because even if you remove that file, let's say TF-vars that has your API keys, right? You didn't put a git ignore, and then you will push it with a random commit. And then even if you remove that file later, it will be in your history, commit history. So you're done. Everyone, especially if it's open source and public, everybody would have access to your API key. So how about having a pre-commit locally so it will just make sure you're not actually doing anything stupid, right? Before a commit, right? And that would even allow you to look smarter next to your team. Who knows? And finally, the commit. I say finally because the sooner your code is compliant, again, the safer and faster your deployment life cycle is, right? Those are, to be for personally, those are really the low-hanging fruits of misconfiguration you should focus on, because checkoff is just a perfect tool for that task. So overall, the DevSecOps paradigm isn't much about how many people you have or how many teams. It's more about where and when can you automate all that security control assessment effectively. One more thing I want to talk about, I told you earlier that I was going to mention another feature, which is the pretty HTML report of checkoff scan results, available for both GitHub Actions and Azure DevOps, thanks to checkoff's output format. So for GitHub Action, the format is serif, right? And this will allow you actually in GitHub Action not only to see the scan result in the logs, but also display them in the code scanning tab. You go to security and then code scanning, you could see all the results. It would show you the snippet and the error and everything. So that's the cool feature too. This is for GitHub Action, right? Code scanning. And checkoff integrates beautifully with Azure DevOps too. Like you can see the graphics are even, better here. Like it looks even better. In this example, GitHub repo triggers your Azure pipeline through a webhook. Well, it's better looking. Good thing is that there's another format that is actually supported by Azure DevOps, which is GUnit XML, right? So what you need to do in your workflow is that you just need to run checkoff with the GUnit XML output format. Then the second task will be called publish test results, right? And this is just going to process that file and publish it in order to be visible, like displayed like in a graphical manner, right? Same thing with Terraform plans. You just need to convert the plan to JSON before running a checkoff using Terraform show. And there you go. At the end, you get the report will be shown on the build page next to the summary tab titled test. So that's so they're better looking actually, because you see all that charts. This is what I want to talk about. And now back to the demo. I think I have to share something. Wait, I'm going to share my screen, present something else. Let's see. So stop screen a little bit. I'm going to share again. One repo. Yes. Okay, I'm going to share this. Sorry again. Oh, select window, the whole screen. Well. Presenter screen 1, screen 2. Let me see if it's screen 1. Yes, good. All right. So in this demo, the first part is more about like the command usage. So I wanted to mention 2 directories. So the first directory is TerraGoat, which is a vulnerable by design Terraform repository by BridgeQ. It has AWS, GCP, Azure, OCI, and iCloud. That's literally this one, right? This is their repo. And the second one is BrokeDBA Terraform examples, where it's my repo actually, where I have like iCloud, same thing, like different repo, different subdirectories with different configurations. So this is what I used. This is what I'm going to use for my demo. And the thing is, so the first command I want to run here is just the one when you want to list per framework. So that's also something that can be interesting. So what you do is you run checkoff list, you specify a framework, and then it would just show you the type of checks as you can see here, the policy, entity, and the resource link. You can click and then discover why, or the description of that that checks. You can choose from a bunch of these available framework. You can see that they have a ton of them. And then in terms of just running the checkoff scan in repository, so I already obviously cloned the Terragot repository. So what we can do is I go Terragot, I go to Terraform, right? And then what I'm going to do actually is I'm going to run one on Oracle, right? Just so to show you that Chekhov is multi-cloud, really multi-cloud, not just the top three. So you can see here that, for example, you got checks around the object storage, public exposure, custom managed key encryption, etc. And if I run this, for example, using TerraScan, because I told you I tested the other ones, right? This is, for example, for Terra Ali Cloud, not necessarily Oracle. But if I use another tool, you know what it says? It says there is nothing. Like there's no low, medium, and high severity type of error or failure, right? What does it say? It doesn't, like, that doesn't mean that the repo or the configuration is safe. No, it just means that they have no checks related to neither Oracle Cloud nor Alibaba Cloud. Right? That tells you about like the big chasm there is in terms of support, right? And even I did a test where I run Trivi on Azure, for example, right? I run this, and then it turns out that I had 100 tests that were run, right? And if I do the same thing with Chekhov, I would have more, maybe the double, right? So this maybe takes time, but I did a comparison with the same repository for the same framework supported by two tools, and Chekhov actually got 231 checks out of that repo, instead of what okay, past checks. I think this is the one I try to say yes. Test. There you go. So you have like half of what Chekhov has. So this is why I just wanted to tell you, okay, if you want to compare two with the other, this is what makes them different. And then I also got my own repo. I just want to show you like the difference between let me see, like the flags, the quiet and the check when you want to specify like one check in particular. As you can see here you have a launch instance in Oracle, which is like a normal instance with like VPC, subnet, etc. So you see that you have the failed checks, you have the check itself, you have failed for which resource, and then you have which file, and then which lines, the line range, right? It tells you everything. I use the compact. I didn't want to show the content, right? But it tells you everything, right? Plus the guide where you can see how to fix it, right? But if, for example, I want to just specify one of them, I'll just specify the check. Oh, sorry. Like this. Check one of them, right? Out of the four specified, I just one of them. And if I want to share maybe the content, this is just what you need to see at the first time. But if you want to say, oh, you know what? I want to see the snippet. I want to see the content. So then I would know more or less what is inside this resource that is non-compliant. You can see that I actually have some ingress security rules coming from anywhere on port 22, right? So I need to fix this one, right? It does secrets as well, but by default, you don't need to specify secrets because it's included by default, right? So this is included with any other. If you don't specify the framework, it's all the framework at once. Software, pretty self-explanatory, so I explained that to you already. And then you have the custom policies. For custom policies, there's actually another repo called Chekhov demo. That's my repo in my own GitHub, right? So I need to actually clone it, but I did it already. So what this custom policy is saying is that, you know what, I want to avoid any local exec or remote exec provisioner to be present in any of the resources within my configuration, right? You can see here, resource type all. I want to check a local exec, remote exec, not exist is the operator, and any type of resource, right? Not exist means that if it exists, then I will throw a failure, right? So it's already defined. I'm in the other one. I'm in here. See, I'm in the code, right? And then, so that file is actually here. Check. Yeah, it's in here. Custom checks. If I go to custom checks, there you go. I think it's even here. No, that's the provisioner. That's the file. All right. So this is the custom policy. All right. That's my custom policy. Right. This is exactly what I just showed. Right. If you go back to code where the file is, right, I can run checkoff this command that will just specify where that custom policy is located. You don't need to specify the file itself, just the location, right? So if I do this, right, I run it, I'm inside code, right? It runs, and then boom, right? Look at this. This is the sneaky malicious code that steals your access key. As you can see here, this script is actually just echoing your access key, storing it somewhere, SCP to a shady host, exfiltrated, remove it without even you knowing this, right? So, and you can sort of recontribute back to the community actually with your policies. Same thing with scan plans. I don't have a plan, but usually this is once you have a plan, you have to convert it into a JSON and then run checkoff on that plan. The demo number 2 is more about I want to talk about pre-commit, right? So pre-commit is very simple. I thought it was complicated at first, but you just need to install the binary. And then after that, you need to create a file. And within the pre-commit config file, locally, we're saying like without any commit, before any commit to GitHub, you can actually just make sure you run your checks. So to prevent you to send whatever in compliant there is as code. Right, in here, you have the repos. You have to specify the repo where the hooks are, right? And as you can see here, I actually specified the repo from our friend Anton Babenko that has a very expensive pre-commit Terraform with a bunch of hooks, but we only want the Terraform checkoff to be used here. You can see that we have arguments. You can use quiet. We can use skip check, framework, compact, define a file or directory. So we can all do that, right? Once you have that file within the root repository or directory, you can actually run pre-commit install. This will just install the hooks, right? So we'll sort of import the hooks from this repository, this one, and then install it. And once it's installed, you can try to modify a file. For example, here I specified this file. If you modify it and you try to add it into your GitHub and try to commit and push, like within the commit, it will tell you, whoa, what are you doing? This one is not compliant. You cannot commit it. You cannot push it. It could be password, credential, or something very critical, depending on the checkoff run, right? But it will keep you from pushing that into GitHub, which is super nice, right? So if you want to skip this, you can do no verify if it's like minor, not a big deal. But if for example, if I run this here, I can run it manually, right? I can do that.
Yeah. Quick heads up. You have about 3-4 minutes.
I got 4. Okay, cool. Perfect. I just want to show this. So this is the pre-commit. So it's local. It's not within your GitHub, not in IDE, but it keeps you from pushing anything to your GitHub. The other thing I want to talk about is the last stuff is the checkoff action, right? The checkoff action, I'm just going to move the, sorry again. Yes, here. All right. So this is not it. Sorry. There you go. My bad. Right. I don't know if you see it. This is the checkoff action. Same thing as the pre-commit. You have all the features possible. You just call this action. That's the checkout. You call the bridge queue action. And after that, you can use every argument that's possible within the checkoff help and run it. And here what I have is I got my same repo, but this is just the workflow. In my workflow, what does it have? It says that for any pull request and push on that branch, right, I'm going to check out the repo and I'm going to use that same action and then run it on top of my directory, right? And then you got a second task that will just try to process that SARI file that I told you about that will like just share like the graphical, good-looking scan result. Here, for example, you see I added something. We don't have time, but I'm just showing you that within my pipeline, I added something, then checkoff was failing. Why? Because it was showing me all of these errors. Obviously, this is a non-zero exit code, right? But after that, the serif is processed. And when you go back to code scanning, you have the result, right? If you click here, you can see more or less, see the snippet, the error, all the details about it, right? This is better than what you saw in the logs. That's the cool part. And once you've done this, after that, it requires a PR, obviously. But the cool thing is that you can protect your branch through checkoff. So you can go to branch protection, choose your branch if you did a PR already, and then you can use checkoff as the tool to protect your branch from being merged. So you get here, you choose checkoff, see required branch to be up. So yeah, choose which status check must pass before branch can be merged into a branch that matches this rule. And then you choose checkoff, and every time, if that is specified, every time you try to merge a pull request, it will actually run checkoff test, and if it's failing, there's no way you can merge it. So this is additional protection for your branch once you actually added all the framework, the workflow with the checkoff actions. This is just the checkoff actions that is playing behind. Right. So I think I'm done. I'm ready for any questions. I'm just going to maybe show my I'm just going to show my socials. My website is WorkDBA. I'm available on Twitter. My handle is clouddude_. You can reach out in LinkedIn as well, or you can check out the checkoff demo repo in my github.com/WorkDBA. And you also got, if you're interested, I got a Tech Beats Unplugged podcast. That's the place to be for tech stuff. And I'm ready for any questions.
Great talk. I didn't know about the VS Code plugin, the HTML report, the baseline, and I'm a longtime user, so I guess I'm just a super basic user. I like that you explained the available commands and flags as well. That was really helpful. And let's hope, I was pretty surprised about the numbers when it came to misconfigured versus compliant repos. So let's hope we can get that fixed and get more people to use Checkr. But what are your thoughts, Karim?
I think applying policy to your infrastructure as code is always really, really hard, especially if you have to start from scratch. So tools like checkoff, TFSec, TFLint, they're all great ways to make sure your stuff remains secure, especially if you're thinking about things like NIS, NIS2, NIS1 as well. Not having to define those policy packs and just being able to, set enabled equals true or clicking in a UI, worst case, is really the way to go. Thank you for sharing this. So with that, we have one more talk to go, but before that, I'm super excited to announce the winner, and I'm gonna do my best with your name here. But Ofente, congrats! You're the winner of one of our swag gift bags from the HashiCorp store. I'll drop you a message on either YouTube or LinkedIn, so definitely respond to that. And with that, what's the next speaker?
Yeah, good one. But before next speaker, just a quick note, HashiConf registration is live. Join us in October 14 till 16 in Boston. For more information, links down below, visit HashiConf.com. Now, our final speaker is Brian Moore, and Brian is going to talk about how he convinces others of embracing the DevSecOps mindset and the way of working. I'm very interested in what Brian has to say, so over to you, Brian.
Hi, my name is Brian Moore, and today I'll show how to make the case for a DevSecOps transformation. When I work with legacy IT staff, There's heavy resistance to adopting IAC, policy as code, pipelines, pull requests. When I engaged people and explained the benefits, the reaction from people was mild. Your little demo is cool, and that's nice in an ideal world. That works for you and your background. But we can't learn all those new skills. We're not developers. We're not a big tech company. We just want ClickOps so we can just get things done fast. I didn't want tools or skills to take all the oxygen in the room. The audience would fixate on the effort of learning and changing, and they'd miss the bigger picture. I just wanted to showcase the culture, the principles, and the mindset first. If they never learn the culture, they'll never touch the tools or apply the skills. So I developed 2 stories that illustrate the fundamental difference between on-prem and cloud, and why transformation is required to succeed in the cloud. I can tell these stories to anyone, and they can instantly relate to it. Then we have a common understanding to build on when I'm evangelizing tools and practices to them. I'm going to move quickly because if you're here, these concepts aren't new to you. But I'll explain the concepts in a way you've never heard them explained before, and then you'll be able to explain them to other people and hopefully change some minds. My first story empowers security professionals to explain why the cloud contains so many threats and showing developers why they can't have ClickOps in production. So let's begin. Your on-prem data center is like your home. You live in it, you built it, you maintain it. You have full control over everything inside it. That full control provides peace of mind and safety, but that full control is limited to a fixed physical space. If I only do business close to my data center, there's no problem. But if I do business around the world in different countries, my data center has limited reach. So what if we started traveling abroad? Suddenly we have less control over our surroundings. We're more exposed. Safety is dynamic and relative depending on what we're currently doing. We need to have situational awareness. I wouldn't feel safe walking unarmed down a dark alley at 2 a.m. in the morning, but I'd have no problem doing it during the daytime, carrying a taser. Situational risk limits your flexibility. But you're not just going to walk around the street carrying your luggage all day. You need a shelter to stay safe. You're going to check into a hotel. A hotel provides best-in-class shelter services without building and maintaining them yourself. Not only that, but the Hilton Hotel is a global network of hotels. Today, I can walk into the Houston Hilton, give them my credit card, and they'll provide me a room to use. Tomorrow, I check out of the room, pay my invoice. I fly to Paris, walk into the Paris Hilton, show them my Hilton membership, and I start using their services there. So we get into our hotel room, and we have similar amenities we enjoyed at home. We have gated parking for our car, locks for our doors and windows, a safe to store all our valuables. So are we safe now? Well, that depends. Safety when traveling is still very different from living at home. The hotel secures their facility, not you. They provide reasonable protections from foreseeable risks. But they're not a daycare. You're not in their custody. They're not your bodyguard. They don't provide personal protection. The hotel warns guests about this. Lock your car. Hide your valuables. Keep your properties with you. Don't be a victim. If you get burglarized, the hotel simply says, yes, we see this all the time. You need to be more careful. The hotel is a difficult target for criminals. The staff are highly trained to detect and prevent crime. They have very mature tools and controls to protect the hotel. Any successful attack is going to be expensive, risky for the attacker, and just difficult to pull off. But successes do still happen. AWS, Azure, and GCP have all been breached countless times. Just watch the news. The ideal crime targets are the hotel guests. They're less familiar with the area. They have a simpler approach to security. They're prone to mistakes. They're often distracted. They're always in a rush to meet a deadline. Look at this picture. Someone propped the hotel door open using a latch. When I was a kid and my family stayed in a hotel, my mom would be in the shower and my dad would be asleep. I need to run down to the ice machine to fill a bucket of ice. I don't have a key, so I prop the door open and I do my thing. I'm sure it'll be fine. But I've introduced risk and created an opportunity for something bad to happen. The hotel is a publicly visible location. Everybody knows what it is and where it is. Everybody knows the public IP addresses used by the cloud providers. All these potential targets are huddled together here. So if I'm a career criminal, I know exactly where to go to find my victims. Look at this picture. If I was at home, I'd be fine with leaving my backpack on the breakfast table while I get some coffee. But in the hotel, I would never leave my backpack vulnerable where strangers can get it. I would take the backpack with me. In the cloud, if I create public storage with anonymous access, then hackers will immediately begin reading it as soon as it's created. 99% of security breaches in the cloud are the customer's fault. This means that even if you could prove that the cloud providers are impenetrable, their staff never make mistakes, the services have no vulnerabilities, the hackers do not have any way to defeat any of the cloud's security controls. This would only eliminate 1 in 100 security breaches, because the other 99 are customers figuratively leaving their backpack on the table or being tricked into inviting a criminal into their room. That's how it happens. When people first think of the cloud, they naively imagine 4 very secure walls that cover every vulnerability you can think of. I'm just going to put my app in the cloud and open all the services to the internet, front end, back end, database, whatever, and the cloud has lots of technology to make this safe. Why would the cloud provider allow me to do it unless it was safe, right? Unfortunately, this is not really true. Instead, the cloud provides 3 very secure walls. Those 3 walls are extremely difficult for a criminal to breach, but there's a 4th wall which you need to build and maintain. So if you put in a velvet rope or a fence with lots of holes in it, then a criminal can just walk in and take your valuables. If hackers could breach the cloud provider's walls, then they could breach any application in the cloud anywhere. But they're not focused on those. They're checking your wall to see whether it has any of the well-known common vulnerabilities open. Let's imagine that in your hotel room, there is a closet door. And when you open the closet door, there's a magic portal into your bedroom, like Monsters, Inc. A private connection. This means that if someone breaches your hotel room, then they have access to your home as well, where you sleep. Now all the rooms and people in your home are under threat. So the stakes for securing the hotel room are very high. Now let's suppose you're going to be living abroad. You're going to be migrating your assets from your home to the hotel and live abroad in hotels full-time. You're going to have a minimal footprint at home. Again, now the security of your hotel room is very critical. Let's look at the traditional security model we have at home on-prem. Again, we have a fixed physical space where we own and control everything inside. There's generally a simple perimeter where once you're inside the network, once you're on the domain, you have easy access to lots of different unlocked rooms. There's lots of lateral movement. You're not repeatedly challenged by locks on every door every time you try to enter a room. You're implicitly trusted. The mindset is that everything outside the perimeter is unsafe, and in order to secure something, we bring it inside the perimeter where it is safe. Now let's look at the hotel. Everything is spread out. We don't have a dedicated space where we control everything. It's not possible to draw a single, simple perimeter line and say, we trust everything inside this perimeter. We're safe inside this perimeter. Instead, we need to put locks on every individual room, and people need to be vetted explicitly whenever they access a room because implicit trust is no longer feasible. Instead of one big flat network, we need to isolate areas according to their function. Kids in the game room don't need access to the office, so we don't allow it. Least privilege access. We restrict public access. Obviously, a parking garage is only functional if I can drive my car into it from the street. But there's no good reason for the bedroom to have a door directly open to the outside. That's a potential risk. People should come in through the parking garage, past the standard security checkpoints, and there's a path from there to the bedroom in the back. But there is an increased overhead from putting deadbolts on every single door in the building, and everyone has to be challenged to present a lock key every time they want to enter a room, or they have to ask someone to let them into every room. And the solution to that is to make the locks smarter, more sophisticated, and more automated. Ideally, I should be able to walk up to a door, scan my fingerprint, and the smart lock lets me in if I have access. That's self-service automation. We have to model what is a normal and safe day in our operations, then restrict everything else. You need to classify your data, set policies around confidential business data so you can apply special controls, preventing it from being leaked. The point is the cloud is not going to somehow magically go in, discover all of our data, and develop a security strategy fit for our operations and classify all of our data for us. It's not a daycare. They'll provide tools for us to do it. They'll strongly advise us to do it, but we need to put all of these controls in place and follow the proper processes to enforce it. Humans are the biggest risk factor in security. They're vulnerable to phishing, malware, social engineering. They make mistakes. They're constantly in a rush to meet deadline after deadline. It's better to grant access to robots instead. A robot only lives for one purpose, like deploying a specific app. That robot stays in one room its entire life. It doesn't travel to high-risk countries. It doesn't get emails or text messages. It doesn't browse guilty websites. It can't be phished. It only follows orders given by code. That code is reviewed by approvers. Security tools scan the code and apply thousands of industry best practices, as well as your own custom security policies. Let's provide app developers security-approved building blocks with built-in guardrails and policy as code. Then users can model their app by connecting and stacking the building blocks together. Once their app is ready, they can submit this model to a DevSecOps platform, which will scan the model, enforce policies, and then deploy the app. Because we're using reusable, blessed patterns, changes become standard and fast-tracked. Security is like a suit of armor. It provides layers of protection which mitigate hazards and risk. When we lower risk, we increase flexibility. Let's imagine working in a chemical plant. Safety compliance requires wearing a hazard sensor while I'm working because chemical gas is a deadly risk. But for some reason, there's no sensor equipment available right now for me. The safety manager tells me, look, I don't want to stop you from working, So I'll give you this respirator mask to wear until I have a better solution available for you. You're not going to like wearing the respirator mask. It's going to be uncomfortable, and it's going to slow you down. But I need you to live with this until we have a better solution in place. Well, I tell the safety manager, I don't want to do that. I don't need a respirator. I'm just going to hold my breath while I'm working, and everything will be fine. The safety manager will say, if I let you do that, then I'm going to lose my job. If you work without the necessary protections, then you are exposing yourself and the company to a disaster. You can do your work only if you comply with the standard necessary protections. I'll provide you with better safety measures when they're ready, and those will be easier to use, but you have to wait. It's simply a matter of protections. If the required level of protection is in place, then I see no issues here. The risks have been mitigated. Go forth and conquer. When you lower the risk, you increase the flexibility. So be street smart. Hackers only need to get past you, not the cloud. If they could breach the cloud, they'd be able to breach everyone. You can't expect the patterns and practices we followed on-prem to work in the cloud. We must adapt and change the way we work. The cloud is a pattern, not a place. It's not just a data center that we're moving all our apps to. We need modern security controls and automation. We need self-service with code and pipelines, not ClickOps. So that concludes my first story. This one focused on dispelling the hype users have about cloud so it would become clearer why they can't just get ClickOps in production, and pipelines and code are necessary to stay safe. Users told me this taught them a lot about cloud security in a very short amount of time, and it was very relatable and easy to remember. Security professionals appreciate the story's ability to explain the security mindset and drive all the key points in a way that's simple to digest. It helped me build common ground with them to start talking about automating security's work. Let's move on to my next story, which illustrates how legacy IT can modernize and transform their operations by adopting DevSecOps and automating their work. When you first start in the cloud, it's like a bank lobby. There's minimal self-service automation. If a customer wants something, they wait in line behind a bunch of other customers for a bank teller to manually review and fulfill their request. In fact, you're lucky if there is a prioritized, orderly line of customers. Customers will skip the line and hassle the tellers directly, saying, "Hey, I need something important. Drop what you're doing and help me right now." It's chaos. It disrupts the teller's ability to get work done. The tellers are a huge bottleneck for delivering service. You can try hiring more bank tellers or optimize the bank teller process, but this gives limited results. You can't keep up with the speed of the business, and the business will have to scale back their expectations on how much work can get done. But this model cannot scale. Eventually, banks developed ATMs, a self-service platform. A customer authenticates to the ATM, asks for a common request, and the ATM fulfills it. Anything unusual requires a bank teller to fulfill. At this point, it's still a manual process. A human must visit the ATM and physically interface with it using their brain, eyes, and fingers to punch in what they want. Requests can't be automated with code. This relieves some stress on the bank tellers, but innovation is still very limited. If I need to deposit a check, I still need to go into the bank and fill out a deposit form and wait for a bank teller to help me. Later, banks evolved to a digital model. So instead of visiting a bank, I just pull out my phone and bank from my couch. If I want to deposit a check, I just take a picture of it and the money shows up in my account. I don't even carry cash or write checks anymore. It's safer to send and receive money digitally with Zelle or to pay merchants by tapping my smartwatch. Banks exposed APIs that allowed innovation with third-party digital products. This spawned huge swaths of innovation in the fintech industry with platforms like Plaid. Banking can be event-driven in real time instead of a human visiting an ATM or waiting for bank tellers to be available. AI and machine learning can be embedded anywhere in the workflow to perform fraud detection, optimization, trading, you name it. Achieving all of this required a total digital transformation of banking operations. A bank teller's role is no longer to toil on busy work. They graduate to building automation of their work. Once you have a mature self-service platform, you don't even need to expose a bank lobby to people. If a customer approaches a bank teller, tell them, "I don't work on that. Go to the self-service platform to get what you want." Once everything is digitally automated, it's considered to be unusual and even risky for a human to directly meddle with assets. Keep assets safe by minimizing human access and letting automation do the work instead. Direct production access is for break glass scenarios and requires heavy oversight. Nobody is going to just give you the key to the bank vault and tell you, "Bring it back when you're done." If an important customer tells the bank, "Look, just let me go in the back and touch my money. I promise not to touch anything I'm not supposed to. I won't break anything. Just trust me. I'll do it however you want me to do it. But it's my money. It's my right to touch it however I want." That will only end poorly. That is anarchy. That is a mess. That does not work. And it diverts resources away from digital transformation to securing human access which shouldn't exist in the first place. Don't ask for ClickOps in production. Ask for a DevSecOps platform instead. Think about where banking started and the journey they made to digitally transform. Despite all the stringent security requirements of the finance industry, today banking is fully automated and accessible from my phone, sitting on my couch. Now think about the work you do in enterprise IT today. How can you achieve that same transformation? An organization must align itself to lead and not to lag behind competitors. It must reinvent the way it operates to accelerate service delivery. So how do we sum this up? What's our mantra for operating in the cloud? First, I'll show you something that I do not agree with, but I still hear people say it. The cloud is just someone else's computer. No, that's no good. You've probably heard this one before, or maybe you've said it. I think when people say this, what they're trying to say is, the cloud is not a daycare. The cloud still needs lots of security controls. The cloud is still vulnerable to threats from everywhere. And that is absolutely true. But these words don't carry that message. Instead, try this. The cloud is technically someone else's computer, but it's really a pattern, not a place. We treat servers as cattle, not pets. Use infrastructure as code. Pipelines deployed to production, not people. Least privilege access. Automate everything. Integrate security throughout development and operations with policy as code. Avoid requiring humans to review and greenlight everything. Humans are great at designing policies to fit the needs of the business, but they're not good at standing at a checkpoint all day long and using their eyes, brains, and hands to enforce those policies. Build automation, robots that are coded with thousands of your policies. They can stand at all the gates and can instantly detect and block violations. A developer can create a package describing all the requirements of their application, the infrastructure services, app code, data classification, permissions, network policies, projected costs. Then they can submit it to a DevSecOps platform which can vet the entire solution across all concerned areas. Platform teams automate policies and guardrails into the platform, and these will assess the application across all concerned areas. The platform emits warnings or rejects the solution if any policies are violated. Otherwise, automation deploys the solution. By shifting the checks left, the developers will cut their teeth on these guardrails from the very beginning of the development process, and the entire lifecycle stays secure. It's important to include as many of the dependencies as possible. Otherwise, you may end up in an anti-pattern where a pipeline can only deploy half of the services for an application. Then, the application team submits tickets to other teams for their dependencies and waits for those dependencies to be built. And then after those tickets are done, the application team runs a second pipeline to deploy the rest of the application. The pipeline needs to be able to provision, destroy, refactor, and replicate the entire solution by itself as much as possible. Otherwise, you've severely limited the productivity benefit the pipeline brings. Let's consider one more example. Think about all the data involved in a bank's operations. 60 years ago, that data lived on paper, sitting in file cabinets, and all the indexing and querying and maintenance was done by human brains and human eyes and human hands. Then databases were invented. Now the database is a co-pilot that handles all the grunt work for you. People can focus on writing code, telling the database what to do. You simply define a model of your solution, and the database brings it to life and enforces it. It's faster, more efficient, and more secure. All the data operations are fully digital with no human intervention needed. Any query you write today can be reused tomorrow and the next day, and so on. You never need to remember how to do a task. You're just running the same code you ran yesterday and the day before that. Imagine what banking would look like if they never made this transformation. You couldn't do any banking from your phone. You wouldn't have any digital wallet or e-commerce. The fintech industry wouldn't even exist. If the boss asks this guy for a monthly report, he's got to fetch 2,000 files from 200 different file cabinets and filter, correlate, collate, parse, and summarize everything with his human eyes, hands, and brain. It's terrible. In conclusion, bank tellers and file cabinets cannot scale. The cloud is a pattern, not a place. It's not just a data center where you put your existing tools and processes into. We need a digital operating model for the cloud. And that's my talk. I hope you enjoyed it. My name is Brian Moore, and I'm a cloud architect based in Houston. I love thinking of ways to teach complex concepts to people. If you found my stories interesting and you'd like to hear more, feel free to connect with me on LinkedIn. Thanks again.
That was definitely great. I loved it. It's become a little bit of a tradition, Bruno, you might not notice, but at the end of day one, we usually have a session that's not just tech, but also the larger concept of it all and how it fits. And Brian's session, congrats, this fit perfectly with that tradition. I'm super glad we had this one. And there goes Bruno. As you can see, we're wrapping up the day. Some of our MCs left the building a little bit early. Others are going to wrap up, so I'm just going to do that for you right now. And really, we're looking back on day one. So many great sessions. I don't think you could actually pick a favorite. I couldn't. We had in-depth code example. We talked about the bigger picture. We had super solid explanations for everything. It was just great. And the best part is we have a day 2 tomorrow. Maybe we'll have another giveaway. Who knows? Our MC team definitely gave something away. I mean, you never know if the second team is as great as we are in that. We'll see. Jasmine.
I didn't want to leave
wrap-up
you
do you have?
alone. I felt bad because Bruno, he took this whole secret thing a little too much to heart, and he left us. So I felt bad. I didn't want to leave you alone.
It's all good. Sometimes you revoke a token and then people just start dropping it. It happens, but you know what? Should we give him a chance to come back?
I think we should give him a chance.
All right, let me see. There we go.
Thank you very much, Kareem and Jasmine.
Of course.
Awesome.
It's the least we can do. Yeah, so please give all of our speakers a virtual round of applause. You can do that by posting at least 15 clapping emojis on LinkedIn, on YouTube, wherever you're watching this. And if you're watching the recording of this, then definitely post it in the comments there. Thank you to all of our speakers. You've been great. Thank you for investing your time. Also, thank you to our audience for engaging with us, asking questions, and just being nice people to hang around with.
Yeah, you all have been wonderful, and thank you very much for attending the first day of HashiTalks Secure. We've talked about a lot, right? Setting up HTTP boundary, the NIS2 directive, securely accessing Google Cloud from HTTP Terraform, and a lot more around Vault and Nomad. I couldn't pick a favorite of today's sessions because they were all really good. And Brian, I wanted to say that you had very valuable lessons in the last talk. Great analogies, great metaphors, and you're an exceptionally well and good speaker. I really liked it. Thank you, Brian. Now, everyone, thanks a lot. Again, the videos will be posted in a couple of weeks on our HashiCorp YouTube channel, and I'm excited to see you tomorrow.
If your token doesn't expire.
I couldn't resist. That was great. That was great, Laurentius.
Yes, thank you, Laurentius. That was perfectly timed. See you all tomorrow. You can hang around for the closing music, but you don't have to.
Yes. Thanks. Bye.
Thank you. Bye-bye.